Oh my. Alright, what's up? I'm just gonna wait for the Discord ping. There we go. Sweet, that ping went through. Now, I might put a message there. Using Twitch only today. Easier to moderate the bots. Alright. I'm just gonna wait for the stream to get a good connection. I don't know why my internet's doing that. Always excellent. Sup, Libya? Hey, this sweet. Oh yeah, doing this is way easier. I guess ban timeout, delete messages, auto mod queue, everything. Let me know if the music's too loud or anything like that. I think that should be okay. I can't tell if my... Oh, whatever. Alright, so in this stream, we're going to be doing some scripting, working on a SCP site that I'm working for. In this particular case, we're going to be implementing a projectile service, which then I can use in our gun system, and then I need to test it, and I need to do some other things as well, such as implementing ricocheting, reflecting bullets off surfaces, and bullet penetration. So we'll look at that. Oh, there we go. Now I can see users in chat. Can I clear that? Yeah, come on. Let me see. Oh. Oh, I know they were. Now I'm in the Roblox Studio section. Right, so I'm going to be basing it off on what's right here. This is the old system that I implemented. I did change some things around. Most of it's still the same. I did change how some of these work, like destroy function. These to here. Also is in global resolver. I've added stepping, so smaller step iterations, just to improve the precision of the projectiles. And yeah. And then yeah, I've gotta do that function down here, but for bullets. Oh, don't need that one. So let's start. So I want to implement the update tick here. So if we go to update delta time, when we have a look here, we've got times it by global timescale. Now I'm going to move that back down here. So right here in between here, I'm going to times that by global timescale. Which I'll do it delta time times equals global timescale. So that way we can slow every bullet in the projectile simulation down or speed it up if we want. And then also we've got global gravity. So I'm going to also jump here. Delta time elapsed plus equals delta time. If our projectile has lasted the length of the lifetime. So if lifetime and so it's a lifetime. So we've got two different kinds of projectiles here. We've got a bullet which may not have a lifetime. It will just travel infinitely until either our projectile terminated function returns true, or our code in other scripts stops it manually. Otherwise, we've got lifetime based bullets, which will Otherwise, we can say, okay, if our time elapsed is larger than our lifetime, the bullet's lasted over its lifetime, so we can just destroy it. And we'll stop updating there. So that's the first part. Now we want to get the next position and next velocity. So for this one, we need to change it so... Actually, I think we'll just do our normal thing first, and then we'll add this afterwards, because when we add bullet penetration and ricocheting, we need some other factors, which I might make a class for, like a projectile config class. And then that's just going to be a table of config for that. But for now, we can just follow along with this. So we've got next position, next velocity. Those are two functions which are up here. They're just basic physics formulas. We've got V0 plus... what is that? No, sorry. That'd be V0. Oh, what? I remember the comment. It's like V0 plus... V0T plus... V... times... oh, I don't remember what that is. That's some formula in physics. So this one is 2. That one's V0 plus A times T. But these ones are pretty much saying, okay, from our current point to the next point in time, what is our position, what is our velocity at those points in time. So we'll mainly need that when we want to figure out where we're traveling from, or where we're traveling to next. And then we'll get our direction that we're traveling. So here we'll do that. Direction. So actually I want the unit of this. And then what I'll say is local. Actually, what was this one used for? Oh, the raycast result. Yeah, so we want the next direction we're traveling, and then we want a raycast result to their next position that we'll end up at. So what we want is a raycast result. Workspace, raycast, our, was it position, direction, next direction, or travel direction, times next velocity dot magnitude, delta time. No, we've got that there, minus this one. Yeah, makes sense. And then we'll use our class's raycast params, or the default ones. That's the other part of this. So if we have a look at the class here, we can set raycast params that we follow along for our projectile. Otherwise, we can use a custom one by setting this. Okay. Oops. Let me get back. So that's our raycast result from our current position to where we're going next. So at this point, this is where we would add ricochet slash penetration slash reflection. So that would be implemented here. We'll get our like angle of incident. If it's too steep, we'll reflect it or ricochet. So that would be reflect. So that'd be reflection there. Otherwise, if we're going on a steep angle, we can see if we're going to penetrate it or if we just leave a bullet hole there. Head clicks. We get angle of incidence, steep angle penetration, shallow will mean ricochet. Yeah, I stream on Twitch and YouTube, but I'm doing only Twitch today. I can moderate easier. Do you join HD? I am not joining HD when I stream. Let's do local ray and oh, let's do ray direction. So the reason behind this one is we want to visualize the beam of where we traveled. So if I do debug visuals, let me actually do it below if the user is true. This will visualize it for us, which is nice. So we'll add that. We'll have the raycast params. Last ray params. I'm gonna change this to last raycast value. So let's add that in here. I'm gonna put that inside this one here. So we got that one. Do kill ray. So this is for when our ray hits something. So this raycast result we just did. If that hits something, we have a function that will determine whether or not we stop the projectile here. So if we have a look at the self dot on ray hit, so this is a function. If we have a look up here, this returns true, so this will stop bullets on default, on hit by default. So you can create a function here. You can make it so if it's grass, you can make it return a penetration. You can make it return reflection, things like that. So you can have special surfaces. So like if you got a Halo game, you can make it just reflect off force fields. And I'll change this later so it returns a different value. So voodoo returns a different value. 1 equals penetrate to reflect, 3 stop. We'll do that. So let's have that there. Let's do that there, because that's where we kill the ray. We want to set our position, we'll set our velocity to these values. So here we'll do, okay, if we kill the ray here, our end position is at the raycast position, that's where it hits something. Otherwise, we didn't have a raycast result, and we're just going to keep going through it. Alright, see you clicks. What I might actually do as well is see this position here. So let's say we penetrate through something. We need a way to set this value to behind the object that we penetrated, or actually we can have it so in our do kill here. So let me actually so instead of do kill ray, we'll have like the job ID. If job ID is 1, which is I think penetrate, then we'll do all the math for the penetration through the object. So that'd be raycasting backwards. It's an algorithm we'll explore. 2 is reflection. So I'll reflect the velocity based on the angle of incidence. We'll get into that later. And then 3 is stop. So that's where we use the raycast result position. Otherwise, if this returns, actually we'll need to keep going. 0 equals keep going. So if that returns 0, then we'll use the next position. So actually, I'm gonna make that return to 0. Oh, sorry, return 3. So 3 is stop by default. What is this? On ray hit job. If on ray hit job is equal to 1, else if on ray job is 2, else if on ray job is 3, then else we want to keep going. So that means we'll have our next position there. If we stop, which is number, what is that? 0 is keep going, 3 is stop. 0, 1, 2. So 0 is keep going. Shut up, Jack. You're a goofball. So here we want to just keep going, so we'll just put it to the next position. Number 3 is stop. So we'll just do a... if we have a look on the right side here, self-destroy. And also we want to set this to the raycast result position, because that's where we stopped. Now our velocity will change based on this. So I'm going to do that there. What's our number 1? Number 1 is to penetrate, penetration. Number 2 is reflect. Oh, I should say ricochet. Or reflect. Is this the Chainsaw Man game? No, this is for an SCP site. I'm probably not going to work on the Chainsaw Man one. I'm not going to lie. So penetrate here. We'll change the velocity of this. So this might be like times equals 0.8 or 0.7. So we'll lose speed by penetrating through the object. And then that can also be a factor up here. So let's also do note factors, velocity, magnitude, figure out penetration depth, etc. So we'll take those into consideration. Penetration there, so we'll do nothing there. So for now, we can probably just comment these out. Or job is equal to 2. Job 3. Remove 2, 3 when implementing penetration / ricochet. Okay, so we've got that implemented now, and then we've got debug data and on-ray updated. So the on-ray updated would mainly be for this one up here. However, I'm going to leave it out here, because here we can return. Actually, no, I won't do that. I'll keep it like that. Yeah, let's do that. We'll keep delta time there. We already handle this do kill ray. That's this else statement here, so we don't need that anymore. And what I might do is actually kill projectile false. I'm gonna run kill projectile equals true here. If kill projectile, we're gonna do this very last. The reason for that is if we destroy it now, this function will be set to nil, and this debug steps will be cleared. Oh wait, no, it won't be cleared, but this one will be set to nil. So we want it to at least call this on-rate updated event, so that way we can finish the last bit of the projectile, like visualization, for example. And then we want to kill the projectile where it won't run this anymore. And looking at that, we have the lifetime. I don't know what this underscore I position was used for again. Oh, initial. Right. I'm going to add that under user data down here. I'm going to actually change it to init over each. So that's saying initial position, initial direction, initial velocity. Now origin's actually a C-frame, and that would be speed. So local velocity equals origin C-frame look vector times speed. So we'll have the velocity, we'll have the look vector, and we'll have the position, which are all correct. And the reason why I'm using vectors over storing the C-frame is C-frames have 12 values, vectors only use 6 if you have the position and direction. So that's why I'm doing that. Oh my god, Jack followed me. Oh. Okay, so now we've got that. That's pretty much most of the projectile stuff done. We do use this debug steps table here, so I'm going to make sure I have that in there. And we have debug data, which is a boolean to see whether or not we actually store that. Do we store debug step data? Visualize with beams. Debug data. That would be ray path with info. Oh, I should say projectile path. If we have a look at that there, so what we have is time elapsed. We've got position, we've got velocity, we've got the job, ray hit job. Let's make sure we add that in there. Next position, next velocity, maybe we should add that. Let me actually put these on multiple lines so we can read it. So we're at our current position, our current velocity, after we do everything. Okay. Maybe I should move that beforehand. Because we set the different values here. I'm going to do that beforehand. No, I shouldn't. What I'm going to do instead is next position is self position, next velocity. So remember, this here is post changes. So this is before, would say, local before position, self dot position, local after position, self dot up after, before velocity. So we'll have before values. Then when we do our ray intersect check or our ray hit check, that will be changing the values, so then they become after values. So after position, after velocity, before position, before velocity. So we'll have the before and after the changes. Like that. So that's just all the ray debug stuff. We'll have the travel direction. That's just gonna, so we don't have to do the before position. That's just so we don't have to calculate it with these values. It will just be there ready for us to use. Apart from that, it's looking good so far. And then what we can also do, so up here we've got an ID. So actually I've got unique identifiers down here. So dispose projectile from UID. It will scan all the projectile classes that are active. It will skip the ones without user data. If it has a user data, it will check it. If it matches, it will destroy it. So that is actually, I was gonna say we need to add a unique identifier generator inside this projectile here. But I don't know if we, I'll do it. I'll do it here so we don't have to do it elsewhere. We'll just create a unique identifier for this projectile in here. What do we think? Okay, if I get disturbed again, I'll have to mute, but we're gonna have generated UIDs here for every projectile now. We don't have to do it elsewhere. And that's this part done. And we can just do our sample projectile generator. So at the very bottom here, I'm gonna make a new function. Function module create a bullet projectile. What do we have here? We've got the local player, origin, velocity. Okay. I might also add a, do I have that in there? We've got a global acceleration. Oh, we do use these, actually. Oh, that's incorrect. What we should be doing is saying, next position is equal to the current position at the current velocity with the current acceleration, with delta time. So we'll get our current position and we'll increment it towards whatever velocity is going. And we'll also take into consideration the acceleration, which is the local acceleration of the projectile. By default, our normal acceleration here would be the global acceleration. I might actually set here. So self-acceleration plus the global acceleration. And we'll make a function to set the global acceleration as well. Function module set global acceleration. Acceleration vector 3. Global acceleration vector 3. And we can also set timescale. Set global timescale. New timescale. 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 We'll dispose of projectiles with that, and now we can go back here. What is this one? Okay, so this is a bullet projectile. We're going to ignore our character, but we want to hit everything else in the game. And what we can say is, okay, if we're running on the client, we want to ignore every other projectile that's running in the game. So I'm assuming this would actually be for us now because of how we're doing it. We want to set this to terrain, as all our beams and attachments will be under terrain. That might be better. Actually, is that default? Does it ignore terrain by default? No, we don't want to do that because we'll ignore terrain then. Table set, insert, wait for projectiles. Do we need that? That would be, oh, so in the RPG game, we had the arrow projectile for the bow. That's what this is for. And that was rendered client-side, so that's why we did, if it's running on the client, then add that folder. But we're using the default beams, so we can see that. We'll create a new projectile data. So we've got base projectile class. We're going to start at this origin C frame. We're going to have this speed. I might just keep it velocity, actually. Yeah, I'm just going to keep it velocity. And that seems like a pain in the ass. Velocity.units. And we'll do velocity.magnitude. So I have our starting position. So actually that would be an origin position now. So we'll have our starting position. We'll have our starting direction, our starting speed for that direction as the underscore init values. So make sure we do that. And origin here now becomes a origin vector. That's a vector 3 in our case. And we've got velocity vector. Now that is all of them. Yep. Our raycast params is this raycast param, so ignore the character. Do I have a function for that? Set raycast. No. So we just set that. Thanks, Webtastic. So we've got that there. We'll set our acceleration. We're not going to set it to global acceleration. We do that automatically now. So I'm going to actually remove that. I'm gonna... Yeah, we don't need it commented. We can just remove it. On here, we've got on ray hit function, but we have a function for that now. So set ray on hit function. We're going to pass the function. And this has to return a number. So in our case, number 0 means keep going, if I recall properly. Yep. So number 3 here. Number 3 here means stop. So we actually want to return 0, so we keep going. Oh no, so we do want to stop. So stop there. If we keep going, it will just go through the world. We want to stop it wherever it hits. Self.userdata.uid. We're going to output that. As ray hit at vector 3 with instance. Yep, that's correct. Oh, this returns a string, so I don't need to do that. I do need to do that though. Alright, we've got that now. Let's set the on-ray updated and terminated to false. So those we don't actually want. We're gonna add this to the add to global resolver, so that's gonna automatically do it for us, so we don't step it by ourselves. And we're gonna return the projectile data. And that's a wrapper for it. So now what I can do is I can delete that. We're going to go into server script service. I'm going to go here and I'm going to require the replicated modules. What we're going to do is replicated modules.services.projectile service. We're going to create a bullet projectile. Oh, we need a player for that. Okay, never mind. Let's move that to a local script. I don't even have Roblox open to test this. Let me open up Roblox. Let's go to starter player scripts. Projectile preview. Lua. We're gonna need the replicated modules. So that's our replicated storage modules folder here. And then we can get the projectile service module on that. Replicated modules services projectile service, like that. Let's also open up where is it? Manufacturing site rework. I'll put it under. Where's Roho? Oh, also, if you didn't notice, Roho did change how it works. So, to get it to work, you just pretty much install Afterman, which it will do through the Roho extension. You click Install Roblox Studio plugin if you haven't already, and then you just start the projects here. And I would listen on the port. You go into your game. Roho and connect, just like normal. Now, I did change how this works, so we don't actually have controllers anymore. I don't use knit anymore. Don't use services anymore. Don't use... No, that's correct. That's correct. Hey, there we go. We don't use any of them. But essentially what we want in this module is our init function. And our start function, which should be on top. Just my favorite comment header. All the systems. And there we go. So we initialize this, we get access to the other modules under the same parent. So that's the overhead labels, the widgets module, which will access all of them. And we got that now, but under start, we want to spam create projectiles that we can watch. So here, I'm going to do a while true do. Let's do a task.wait. Let's do like 0.1. Let's go projectile service module. We want to create a projectile. And our local player will be rec client modules. I don't need that though. So we get our local player, we get our origin vector. So we'll just put that in the middle of the world at like maybe 20. And then this velocity vector, let's create a random velocity vector. So with this one, we want it to go along the X and Z, but we don't want it to go on the Y. We want the Y to always point down. So here we've got minus 10 to 10, and we're going to divide that by 10. So now it becomes minus 1 to 1 with 1 decimal place. And I'm going to put dot unit here, and we'll times it by, let's say, a speed of 5, or a speed of 3. So we'll start slow and then slowly build up speed because it's traveling downwards, and due to gravity, that happens. And then that's our projectile data, underscore equals that. And apart from that, we can probably see what happens now. I'm just gonna run this first to make sure there's no problems. Like that one. Event is not a element of utility. I required the wrong module. Let's go back up. Event class, script.parent dot classes. Oh wait, script.parent dot parent dot classes dot event. Script.parent dot parent dot utility dot visualizers. That's correct. And just to make sure, yep, that's correct. Properties table. Wait, that is right. Duration. Is that needed? Oh, I can just set it to false. Okay. Let's set the duration. Oh no, duration's 2. I'm going to increase that to 4. But if we just run this again, we should be good. Yep, no errors there. If I play the game now. Attempt to call with invalid arguments, projectile preview, line 2. Whoops, that's that one. But let me just make sure that's not ref client modules. Oh, I need to change my snippet. Snippets, lure. Don't require the local player. Okay, wait for child, replicate modules, line 5. Wait for child modules, another snippet issue. Let's configure snippets. Acquire modules. Fixed. That's a mistake on my part. Okay, index null with position, projectile service 128, update. Raycast result. Next position. Okay. So if we have a raycast result, so if it hits something, we'll set that position there. Otherwise, we'll just set it to next position. Oh wait, no, it's supposed to be 1 or 2. That's why. We've got attempt to call Boolean value 187. Let's have a look. If not self is destroyed. Oh, so we've got a function called is destroyed, and then we've also got a variable called is destroyed. So I'm gonna remove the is part. And I'm just gonna have destroyed. Let's spawn in. Under terrain, we should see a bunch of attachments. There's quite a number of them, actually. Where do we spawn our projectiles at? 20. 0, 20. 0, 20, 0. Okay. Let's print our projectile data. So we can print it out and we should see what our problem is. Okay, so our initial position is 0, 20, 0. Our direction is -6, minus 0.6, minus 0.7, minus 0.2. So what we can do with this is game.selection get 1. So get returns a table of selections. You can get the first one, which is our part here, and we're going to set the C frame to a cframe.new vector3.new 0, 20, 0. vector3.new 0, 20, 0 plus vector3 new 0.6 minus 0.7 minus 0.22. So that is the direction that where our projectile is traveling. Our initial speed is 3 studs a second. So that's probably why we can't actually see it. So what I'm going to do is go to our projectile service. I'm going to go to the global timescale and I'm going to put it right down to 0.05. And if that's still too quick, I'm going to set the iterations it does to 1. Destroyed is true. Okay, so it's immediately destroying. That's a problem. Let's go to destroyed equals true. So we call our destroy function here. That would be self-destroy. So if it is larger than the lifetime, or if we kill the projectile. Okay. So on our ray hit job, what do we have? We've got create water projectile. Let's scroll down. So set on ray hit function self, return 3. What does 3 do? 3 does a stopping. Okay. So what we actually want to do is say return raycast result and 3 or 0. So only if we hit something, we want to stop, or... Wait, no, that's not correct. That should be 3 anyways. On ray hit, so let's go to our on ray hit. Raycast result, end self, or false. Oh, or 0, which is keep going. Okay. Oh, lucky I found that. So when we have a raycast result, if only we have a raycast result and we've got our on ray hit function, which we can check what we're doing next, we want to use that value which is returned from the on ray hit function. Otherwise, if there is no on ray hit function and we've got a raycast result, we want to use 0. Otherwise, if there is no raycast result, we want to use 0. That way, it's either if there's no on ray hit function set, it's always just going to keep going. Otherwise, if we have an on ray hit function, it'll stop. So like here, it's freezing. So that is working correctly, except we've run into an issue where is in global resolver, fragile classes. Let's table.find that there. Let's see what we're up against. 101. Visualize the beam, our current position to our next position, 4 with that. Let's go up here to our step iteration and set that to 1. Our global timescale, let's set that to half. And run to our stepping here. And you'll notice that we're doing it at heartbeat. I'm going to change that to task.wait 0.1. So it's going to update every 10th of a second. So now if we come back here, unfortunately it doesn't look like we're actually seeing the projectiles. And we do control. Okay, so we've got parts here, which is cool. Is there no beams? What happened to the beams? Oh, is it in between these? Is that why? There's a lot of attachments. What's going on there? 411. Update at the delta time divided by that. That's global time scale. That's 0.1. I'm gonna make this hostile weight 0.1. I think the delta time 1/60. Actually, we'll do a heartbeat weight then. We'll force it. Looking at our projectile class, update, debug visuals. Now that is enabled. Let's turn off debug data. Let's just have the visuals on. Let's go to our preview here, and instead of doing that, we're going to set a direction, which will be along the z-axis maybe. Let's do like 10 along the z-axis. So what we should be seeing is not this. Okay. Let's print some values. Let's set the lifetime to 2. Let's print point. So that's going downwards. There's no velocity, which is an issue. There is gravity because it's going down, but there's no velocity. So if we get position at time, acceleration times time, so that's using it. Travel direction is our velocity dot units. Yeah, so that's our velocity times delta time. We don't need that travel direction. That's part of the velocity. Our delta time should be very small. Let's maybe... It's starting in the wrong spot. So we've got it starting at the origin position, which is at Y20. But it's not starting at Y20. Sadness that we... Wait, no, I do want to add that. Filter time. Data class updates. Okay, let's get rid of this one. And let's just have it update at normal filter time. Let's get rid of the step iterator. So we're working with just a normal standard time. Let's get rid of, no, we'll keep that. Heartbeat. Make it slower so we can see it. Debugging would be like, why? Spawn in. Okay. Same issue as before. Positions at 0. New at 0. Position. Oh, there we go. Position is origin. Velocity is that one. Acceleration is none. It was the starting values which were wrong. There we go. Okay, now we can see the projectile traveling. That's a lot of fucking attachments, holy shit. Now let's also turn off the point or the attachments so we can see the beam at work. Now where is it? There we go. So that's our projectile there. That's going downwards as well. And what we can do is go to the overview here. Let's set the lifetime to 5 seconds. So that should be enough time for it to go and hit the ground. So if we look at that, it is not apparently. I guess it's traveling too fast for it. Let's do 2 there. Do we change our velocity? Yes, we do. Okay. Let's also set this to velocity equals vector3.new. That's stopping, so our velocity completely stops. Okay, there. So that's traveling a lot better now. Times equals global scale. Our global scale should be... Oh, is that... Let me change that back to 1. Update delta time. Let's go back to the class. So when we update, so our time lapse plus equals that, our lifetime. It's 5 here. That's 5 full seconds. I don't know why that's not doing it properly. Self-acceleration plus global acceleration. At time would be the delta time. Yeah. Maybe I should use... So global acceleration is not under the effect of delta time. Local delta acceleration. Oh, I know that is correct. Yeah. Delta acceleration. Wait, what would that be? That would be. What's the addition of everything together? Net acceleration. So we get our net acceleration, our next position, our next velocity. Ray direction. Ray param result. Next velocity would be this. Or next one minus. Yeah. Sort of velocity times time. Get velocity at time. Okay. What I can probably do is if I print the next velocity and we have a look at output, it's going to print out all the values for it. Okay, so our velocity does not change. Does that mean it's not finite enough? Let's print delta time. I have a feeling I'm gonna have to move the stepping inside the loop. Yeah, that looks like it might be oh I know, there we go. Net acceleration, that's why. There we go. That's correct now. Because of strong gravity, it's going to drop really far, really quickly. Now that we've got that happening, that's correctly implemented. Let's increase that again. Let's go set the set global timescale. Let's do half. Let's step iterate. Do that 8 times. Let's re-implement these. Step. If it's destroyed, remove it. Otherwise, update it at the step iteration, which is sort of time divided by step iterations. Sweet. So set global timescale, set step iterations. Let's do 4. Let's do function module set step iterations new count step iterations equals new count, and then what we can do is let's increase this velocity again. So if we do that, class, we should see it. Yep, there we go. There we go, so our projectile is working now, and it's got a pretty good path. I might reduce the gravity. Let's do 0.15 maybe. Give me a second. Lower. There we go. If we have a look at that, that's pretty nice. And then what we can do is actually spam a bunch of them. So if we do 4i equals 110. So we actually want to set that out here. Only need to do that once. Let's create a boiler projectile. Our local player is ourself. We're going to create out the position there, and our velocity is going to be vector3.new math.random. It's actually just be math.random. Math.random. Let's do like minus 30, 30. Yeah, 30, 30, 30, 30. We don't want to make it go up or down. It was just going to be around in a circle. So they'll shoot, if I'm looking at the part, is there a part? So if I'm looking at the part top down, it will shoot out in a circle, but it won't go up or down. And let's do like 20 of them. So we have a look at that. That was quite the performance hit. Let's get rid of the print. There we go. So that's actually doing quite a bit of a hit on performance. I go over here. If I go up to this loop here, let's do local s clock os.clock, And let's print os.clock minus the s clock. Update duration. So remember, we're doing 0. Oh, no, we're not. Let me slow it down again. So this will tell us the duration of one cycle of this update here. I'm gonna increase that to 10. Let's set that to like 3 for the moment. So here, our clock cycle is really quick. And then we should see a pretty big hit. So there we go. So we had a full second of it updating. So that's a problem. So what we need to do is figure out a way to fix that, essentially. And if we have a look at the number of projectile classes here, what we should do is actually flip that. So let's do that in there, rather. So we loop through each projectile. Is that correct? Yeah, that's correct. Delta time divided by that. So that's step iteration, that's number of steps. So instead of doing 8 loops of looping through every projectile, we loop through every projectile and update it 8 times. That's going to be a lot better. So instead of n projectiles times 8, it's n plus 8. Oops, wait. I know it's a different way of calculating it. What am I thinking? So yeah, no projectiles. If we just let that do its thing. So we got 1.28, but our computer didn't freeze, which is the difference. I'm just jumping. Oh, it does freeze. Okay. 1.4. Are they all going in the same direction? Create projectile. Create projectile. I can't think of why that's doing that. Maybe it is to run service to a heartbeat thing. Connect function. Delta time. Delta times equals that. Step that. Like that. Let's timestamp that as well. Oh, I know what it is. It's gonna be a weird thing where this is gonna have like 500 in there. So let me print a number of these. Let me change that back to 1. So create bullet projectile. When it's added for each one. Unless I'm stupid and I don't increment. Never mind, found it. I didn't increment the index. So it was continuously updating the same projectile until it finished. That was the issue. There we go. Okay, that makes more sense. Tiniest of details. So that's actually working now, which is great. I'm gonna increase the speed though, so we can see this better in action, and we can summon 20 of these at once. So if we do that, If we just watch, we can see all the little projectiles launching. And we can actually speed this up a lot more now. Let's do every like 0.1 seconds. And I will also get rid of this here, which for some reason doesn't show the source of it. It's weird. Let's go to projectile service. Let's go here. Let's comment that out. Comment that out. Comment that out. Now that's working correctly. And that might be too many projectiles. Let's see how many that is. Because we do 20 every 0.1 second. Maybe let's do like 10 every half second. Yeah, so we're at like 40-ish, 50-ish projectiles. Now another issue we do need to face is if I go to here, I need to make it so our debug visuals here and our debug data is turned off. So if I turn off, debug data is already off, that's fine. Debug visual shouldn't be creating that much lag. I guess just because we're doing so many steps. Let me set this to 2 by default. Let me comment that one out. Oh. Also, let's do... where is it? If run service is client, then it's only print on the client. We've got about 50 projectiles going at once. That's at half time scale as well. Let's have a look at the information here. Let's see how fast that updates. And then I want to also implement a multi-threaded implementation of it for a large number of projectiles. Oh, I need to also put that inside a is client statement. That's updating pretty quickly. 0.2. Let's see how many we can get to. So we can do, what, 20 projectiles every half second? So about 90-ish. So we've got 20th of a second. It's a little bit laggy. Probably because of the attachments. Let's turn off the debug visuals. If I turn that off there, and then I try this again, it should be a lot quicker. Yeah, that's a lot quicker. So the reason behind that is because it was creating new attachments, then it was creating new beams, then it was parenting the beams, it was moving, you know, positioning them, all of that. So that took a lot of performance. I didn't use a cache system for it either, so it was creating new instances every time. But here you can see our update speed is insanely quick. And what I can do if I want to visualize them is go here and add a update step function. So if we go to the projectile class, we can have a look at the set updated function here. So let's do a function there. We have the self, and we have the let's see what's passed into that actually. Right, updated. We have delta time. And what we can do inside here is visualize that projectile itself through this method here, using one beam rather than creating and destroying a bunch. So what we can do is local attachment 0, attachment 1, beam. Actually, I need the visualizers module for this. Let's grab that. Local visualizers module. Workload modules dot utility dot visualizers. Let's do under our visualizers. Let's open that so we get a beam. So every new projectile will get a beam. Our start position will be. Let's actually move that here. Local beam. So that would be the underscore init position. And we'll add the init velocity. So we'll have our position, we'll have our offset spot. Our duration we're going to set to false, so that means it won't disappear. And our properties we're going to set the color to a new color sequence, which is white. Actually, let me make that thing up here. Like beam properties equals that. The instance. What I'll do is beam dot no, I want to pass in local step data. Let's actually just make this table here anyways. And then we can pass this into, let's do also delta time equals delta time. Let's pass that in there. So we'll store it if we have that enabled, and we'll also update with all this information here. So then what I can do is step data there, if step data dot, oh no, not if. We want to do beam instance dot attachment 0 dot world position equals step data dot before position. The 1 will be the after position, so that's, we can see where it's traveled. And then that should be good. And then we can also say on terminated. So when our projectile has terminated, we'll destroy the beam. So we'll destroy that beam attachment. We'll destroy that attachment, and the beam is parented under node A, so we only need to destroy attachment 0 to destroy the beam as well. And with that, we have optimized that visualizing the projectile. Let's also move this variable, random velocity. Let's move that out here. I need that one there. Let's also set the origin velocity up here. Like shared origin. That'd be there. Just so we're not creating it every time like that. Yep, that's correct. That's what we want. Okay. And let's just do function module summon projectile. We can do a copy paste there. So we've got beam properties and shed origin. We can just put those variables up there. And we can just call that method every time we want to create a projectile. And that's a lot nicer. Then we go back here, we play again. You'll see it's highly performant, and we should be able to see the projectiles with the beams. If those are added, that is. Let's reduce the speed that they travel at. Oh, I know, we'll set the global scale is there. Let's just enable the debug again. Debug data. No, we want the debug visuals equals true. Let's just enable that again real quick. So that should be... Oh yeah, that's visualizing it, that's working. I guess we're moving way too slowly. What we can probably do is actually local last position, local last, or last clock. Is it clock or is it time? I think it's time. Down here we've got update delta time. There it is. So we'll do time elapsed, plus equals step data dot delta time. If time elapsed is smaller than 0.2, then return. That equals 0. And we'll do last position is that one. There we go. Our last position is the inch. There you go. So we're doing it this way, so that way we update it every 0.2 seconds so we can see the giant distance it covered, because we're incrementing it very tiny at the moment, and it's just, the beam's too small to see. Also, I just saw an error. Project 26. Init velocity. Oh, init direction times init speed. I just call that velocity. I don't know why I did that. Init direction, init speed, let's do init velocity. That's one less piece of data to keep. Alright, there we go. I wonder why I couldn't see it. Okay, so we've got all the other ones. We've got the tiny ones as well as the large ones, so let's clear the tiny ones. So in our... Oh no, that's correct. And we just need to make that smaller. Let's do every 0.1 maybe. Debug visuals, but that's disabled. Right, debug visuals, yep, disabled. Hey Copics. Right now I'm doing a projectile system. So I'm just testing projectiles here. This is updating every 0.1 seconds. These are the different projectiles that are flying around actively. And yeah, I'm just making it so you can visualize it and have a look at them. So here I'll make them smoother. So as we add more and more, or as we make this smaller and smaller, let's actually do, what would it be? Inner velocity times 0.01. That's what I was thinking of. So that fixes an issue, but no, it's not lagging, it's just the speed at which it's going. This is, so these beams are updating every 0.01 seconds, but our projectile system itself is updating at every 0.005 seconds. So, but here you can see that we're actively doing 100 projectiles and it's chilling at a very small update speed, which is good. So if I chuck this to 200 now, we'll have 200 active beams traveling with it. This one might be a little bit bigger, so yeah, we've got a lot more. But as you can see, even with 200 bullets, it's super performant. And that's... Oh, sorry, we're at 1,000 bullets because we're creating 200 every 0.5 seconds, but they last for 3 seconds. Or 4 seconds. Unless they hit something, so... Yep, that's looking good. Now let's also add some Y value to this, and let's make this last a little bit longer. Make sure it doesn't go off the base plate. I'm going to reduce these to 80. And then we're going to go math.random minus 10 to 10. Yeah, thanks, dude. So here, if we have a look at it, you can see some projectiles are going up and some are going out. And then some are just going straight down. Now let's give this a real good brute test. Let's go to our preview again. Let's chuck this to 1,000. Also, I'm going to need this for the development log. So now we're actually getting lag, 0.03. But we've got around 4,000 active projectiles, which is pretty dang good. Which I should probably include this. Using Gyazo to take a GIF here. So 4,000 active projectiles, we're updating at 0.04. I'm going to use multi-threading to improve this as well. We're going to have a look at that. So if I stop the game here, I go here. I actually don't know if this will improve it, but we're going to find out. So I'm going to find this part here. I'm going to copy this loop. I'm going to paste the loop again. I'm going to get rid of the comment code. So this one here is update each one individually and wait until it's done before updating the next projectile. And then in this one, I want to increment it on a multi-threaded basis. So if I do task.defer function, so defer will apply it over multiple frames, and because we're using defer, it will go furthest out. So it's like, imagine a table, you've got the first couple of projectiles adding to the table, and then you got more projectiles adding after that. So it's going to do the update functions on the previous run service heartbeat loop first before doing the next heartbeat loop updates. So it's still going to stay in order, but it's going to be spread across multiple frames. And here I'm going to update it on the step interval basis, and we're going to set updating equals false. So essentially it's going to say, okay, if it's not currently updating, set the updating to true. We want to do all these steps under a new virtual thread. We're going to do all the steps. We're going to update it at the delta time for that projectile. Once we do all those step iterations, we're going to stop updating it or set the variable false so it can be updated again. And whilst we set up the new thread, we're going to increment to the next projectile and set up that task.defer. So we've got two types here. So this is the update each one in a new thread. Does not wait for the... Oh, I want to say due to how defer works, any newly called update... Oh, no, that's not it. Due to the is updating field... Oh, actually, it's a flag. It will only update projectiles that are not currently updating. So that's just a note there. Let's have a look at the timestamps right now. So we've got 0.063, 0.06. So about 0.06 for this one. And then let's see what this does to it. This one should probably be more up and down, but it might be quicker, you don't know. So that one's actually, my graphics doing it, but it's actually updating a lot quicker. We're at 0.0576. That's definitely helped. And we're reaching the 4,000 projectiles mark. So if I go back to this one here, I comment these out. So if we use that one thread to loop through all of them and update them all, you're going to see that we're at 0.03, so we reduced it by a tenth of a second. We can see that it's sometimes it's just under 5,000, and that's because we're adding projectiles faster than we're removing them because of the lag under that one thread. And in some cases, you might get double updates, which is an issue. So some projectiles will be faster than others. But by doing it this way, we don't have that issue, which is great. Oh, and that's an added bonus. So even if this lags, because this variable here determines whether or not the projectile is updating during that time, even if a new heartbeat started, it won't update the projectile because it's already updating. Unlike this one, which we don't have that. Which I could probably easily add anyways, but I'd rather have this, which does it across multiple frames and so on. So I'm going to clear that, and what we're going to do is go back here. So that's running 1,000 at a time. I'm going to disable the visualizer. Or I might increment it so it's higher. So if we do that, that should be less laggy. Let's try that. Yeah, so it's lagging less, but visually it's slower. Because we're only updating it every 0.1 seconds. So we're just reaching under 5,000 there. So here we're not lagging, which is updating it slower. But if I go back to the code here, I go to our preview. And let's say I want to defer that on a new thread. And let's do 3,000 projectiles at once. So here we've got 17,000 projectiles. You can see that we're actually not lagging in terms... Oh, no. Yes, we are actually. Because we're using heartbeat, which is a variable, which will change with frame rate. What I would do want to use actually is... let me go back here. Let me reduce that. Let me turn off all the visualizing. Because that's actually causing a lot of lag. If I do that... Let's set the terminate function to spawn a attachment there. Under the visualizer module, we want to spawn an attachment, position duration. That would be the current position of that, and the duration would be 1 second. So this is where everything is going to hit. And if we run this, because we're not doing beams anymore, it's only going to create attachments when it hits things. So here you can see it's hitting all over the map. Now attachments are laggy themselves, so I'm going to have frame rate issues, but you see we're about 9,000-ish projectiles with not much lag. The only lag is my rendering. Data wires, if we just turn this off as well, you can see we're easily reaching 10,000 with no lag. Now it is jumping a little bit. That's just because I'm creating a sheer amount of projectiles here. I'm going to change that to a non-defer one. There we go. 8,000. Just under 10,000. That's a little bit better. If I have a look at F9, not F9. It's under microprofiler. I forgot how to use this thing. Let's dump it. 128 frames. Oh, did that work? No. Okay, I can't figure out how to use it. I was going to show you the profiler, but apparently not. But yeah, just because of the sheer number of projectiles, we've got no issues there. And also that's on timescale half. So if we set that to 1, the projectiles are actually going to finish quicker because they're traveling at normal speed. So there we're only reaching 4,000, maybe 5,000. Okay. Yeah, so even if we reach quite a high network traffic trying to create projectiles, this system's going to handle them like a piece of cake. And not to mention we're also printing twice. And we're doing a clock measure. So if I get rid of them, it's going to be even smoother now. Yeah, so we've got like a cliff edge thing there. Okay, now that we've done that, that's definitely implemented there. It's going pretty damn well. I'm going to reduce this back to like 50. I'm going to include the visualizer. I mean, I'll do it the attachment way, so it's not as heavy on performance. No, I'll do it the cool way. So that we can see it. And then what we need to do next is the actual gun system, which uses this module. Now for the gun system, I'm going to be doing client-side rendering, server-side pure data. So what that means is the server side is going to have its own projectile service running in the background, but that does not replicate to the client. The client's going to run their own system, the server's going to run their own system. The reason for that is the client's going to visualize bullets like this, the server will not. The server's going to be empty like this, and it's just going to do pure data. When it hits something, it's going to check for a humanoid. If it finds a humanoid, it's going to deal damage. So on. So that's important, but yes. For comparison, if we have a look, let me pull up the Gyazo gun system. Let me just find this for you. So if I show you this FPS framework thing that I was doing in the past, we're going to do something like this, where we can shoot tons and tons of attachments at a NPC. Because we can handle a high number of attachments, like thousands, we can do something like this without any problem. And that's pretty much doing this system here, so... Except that one's slower. Okay, now that we've done that, let's go to our server. Let's implement a new gun service. Let's do require replicator modules, require server modules, and I want the base framework. So that's what all of my modules start with. And let's do function module equip weapon local player tool, maybe something like that. Or should I do register weapon the tool? So then we can have tool.equipped connect function, tool.unequipped connect function. We'll need a made instance, local tool made instance. That's local made class module, modules.classes get made. Made is just a cleanup utility. So when I call cleanup, it's just gonna clear all the events we give it, and all the functions will call. So here, whenever we call tool made instance :cleanup, it will clean up this equipped connection, this unequipped connection, this activated connection, things like that. Let's also on destroying, actually we'll do deactivate as well, but on destroying, we want to do the cleanup. Like that. And then here we'll also do while... Oh, actually I need variables here. Local character equals false, local player equals false. So when our tool's equipped, the tool.parent is the character, and the local player is the players. Get player from character, the character. And then we say when it's unequipped, we just set that to false. We set local player to false. We could move this into a class or something maybe later. Here we'll say if character and local player, then a while character and local player do. And then also we want a variable for holding trigger. So here we'll have holding trigger equals true. When it's unequipped, we want to hold trigger equals false. When it's deactivated, the hold trigger equals false. When we destroy, we want to set hold trigger to false, and we want to clear character and all them. So we're just removing variables, removing events, making sure we clean up everything. That's very important. So we've got continuous shooting. So if we register a tool now, this should work. So if I do module register tool, we'll do players.player added connect function, and then we'll do local player character added connect function character. Let's do like a local pool equals character wafer child pool. So here, if I go back into Studio, go starter pack, give myself a tool here. Let's do can be dropped false, manual activation only, requires handle false. Actually, I'll name that garden rather than tool. Oh, I have backpack disabled. Let me just re-enable backpack. Here game.start GUI set core GUI enabled, enum core GUI type backpack true. There's our backpack. We can equip the tool. If we have a look inside our character here, we have a gun. Except I'm stupid and I did not do character way for shotgun. Oh wait, that is right. Print gun equipped. Print gun unequipped. Print gun activated. There we go. We'll do that. Usually we won't do it this way. We'll have like collection service, instance added signal. True science team. Oh. So if I equip that, we've got gun equipped, we've got unequipped, I've got holding. Okay, it doesn't look like activated's working. Hold activated. Holding trigger to all character and local player. Local player and local name. Or player. That should be working, but it doesn't. Oh, manual activation. That's what it meant. If we go back here, manual activation only. Let's turn that off. There we go. So now we're shooting, and then we deactivate. We're not shooting, and that's pretty much what the base of a gun would be. What I might do is just local tool equals instance.new tool. Tool.name equals fake gun. Tool.requires handle equals false. Tool.can be dropped equals false. Tool.activation manual equals false. Tool.parent equals local player.backpack, and we're going to register that tool. So that way I can test the gun system with that only. So when we register tool, we're going to go here, we're going to go, okay, we're shooting in this spot. Let me actually disable this here. I'm going to do pretty much this, whatever we're doing here. Let's grab the projectile service. Let's put that here, below the main. And we're going to we need to register it under collection service. Maybe we'll just fire client. Well, we're doing the server for the moment. Right then. We'll just, so when we activate the tool, remember how I said the client's going to visualize it? I'm going to have to fire clients and ask them to visualize the projectile. So here we're going to do remote service, replicated modules, .services, .remote service. We're going to have our bullet visual event, remote service get remote. We're going to have the remote name be bullet visual event, and we're going to have a remote event, and it's not going to be a bindable, or it's not going to be localized. It's going to be a shared one. And here I'm going to fire all clients. Tool.handle position. So I put tool handle C-frame. So tool handle C-frame. So this will be different, but that would be 50. And that would be the local player. So So that's going to visualize for all clients, but we're going to create a bullet projectile up here. Let's make a function for it. Create bullet projectile. Actually, that should be here, shouldn't it? Oh, not here, in this one. Yeah, so we've got this bullet projectile one here. So what we'll say is, oh, we can simplify this. Now think about it. Instead of having these here, or this visualize here, we'll just call that projectile service module, create bullet projectile, local player, and then it's these two values. Then we move these ones. Let's move these. Oh wait, not that one. We want this one. Let me move this remote here into the projectile servers at the top. Now, why at the top? The server and client requires this module. So when the server requires it, it's going to create the remote event if it doesn't exist. If the client requires it, it's going to wait for the remote event to be created. So in our case, that's good. And then our remote service is require script.parent.remote service, as it's under the same folder. Bullet visual event, we'll get that remote, and we'll fire client all the information. So if we do up here, so if run service is server, if run service is server, then we're going to fire all clients. We're going to have the local player first, the origin vector, and the velocity vector. And then down here we're going to say if run service is client, when we receive a client event for that. On client event, let's just have those. Now, do realize that these are both using this ray on hit function here, but when we implement our own different types of bullets, we're going to have to create a database for them, which is under this data folder here, which is all the settings, for example. So we'll need a settings or database for it, so that way we can pick which one we're using like an ID. But for now we're not doing that, so we can just go ahead and use this. And we can say, okay, when we receive a on-client event for it, we're going to visualize the bullet for ourselves. On the server, it's not going to visualize. And then here in the projectile data, what we can do is, if run service is server, else we're going to do this visualizer on the client here. So here we won't have beam properties. Maybe I'll grab that. Beam properties. Is color not the right one? Let me have a look. Beam color. It is. There you go. Oh, I remember what the problem was with that one. In my visualizer module for my beams, I set the brightness to 0 by default. But that means no color is visible, so I need to set that to 1. Apart from that, so if it's the server, we're going to tell all clients to visualize it. If we're on the client, we're going to visualize it. And we'll just need the visualizer module for that, so let's require that. Right at the top, that's the visualizers here, so we can just use that. And there we go. So now if we go into the game, we should have a working gun tool. I'll need to get that. So if I click and hold, handle is an available mirror of fake gun. That's correct, we don't actually have a handle. So what I need to do is go on the server here. When we create our tool from scratch, I need a handle. So let me grab the handle here. I think my mic cut out, but we just need to create a handle. We're going to do handle.size equals vector3.new 111, so it's just a square. Pass shadow false, Kenclide false. Let's do anchored false, so we don't get stuck. And touch false. Can query false. We won't need any of these on at all. Massless, that's important. Let's make sure that's true. And then we'll parent that handle under the tool. And then after all of that, we'll parent the tool to the player's backpack. So now when we hold this tool, the handle is going to point out from the character, which is where the bullets are going to spawn. And also, whilst we're at it, under our gun service, we're only creating one projectile in the look vector of that handle. We'll come back in a minute and we'll make it spread around a little bit, which will be nice. Okay, let's go in here. Let me get my backpack again. So if I click and hold, handle... Did I name it handle? I don't think I did. Dot handle dot name equals handle. So when I spawn in, I equip the tool, we can see we'll get a part there now. If I click and hold, we're shooting a bullet. So that's only shooting like a bullet every so often. Let's go back to the server side and increase the rate which we're shooting the bullet. So it's going to be task.wait, 1/60th of a second, I believe. Or heartbeat duration. So now if we get our tool again and we click, we're going to have a constant rate of bullets. Now let's add spread to it, which to do that, I'm going to go into my other studio, my old gun framework one, and I'm going to grab my spread function, which I'll use temporarily in our code here. So if I go under stored projects, I think, gun framework, that would be under SCP rundown, maybe? SCP rundown, FPS framework, let's grab that. Oh, okay. Oh, come on. Never mind, let me open up a new place file. And copy that to pictures. Let me open up from pictures, that one. So in here, I did implement the gun framework like we just did, except I'm looking for spread now. Let me get spread. So I'm not going to explain this, how the spread works, but it's pretty much spreading it around in a cone-like shape. And then if I go here, let's go direction, or tool, angle. Yeah, so we get a random angle in a circle, and then we apply that to our tool handle C-frame. We grab that. So we got our direction, times that by 50, and we can change our spread here. So I think what I'll do is local default test spread. I don't know what the values are. Let me check what the values are. Whilst we're here, I'm going to show you this config here. So this is like a config I'd make. And we'd have our spread value here. So this would be 0.05 by default, I reckon. That's for a G36C, so that's the diazo I showed you. You can see we've got sounds here, we've got ammo values, we've got firing values, damage values. So I'll be doing something similar for our gun system for this SCP site. Okay, now that's done. Let's go default spread. Let's change this here to the default spread. I might change that to a function. Local function get spread vector. I'll get spread angle. Return that. Spread value. Let's just return the spread value, which will be the default test spread. I'm just going to move that up here. I want to try move away from C-frames for this, so it's faster, but I won't worry about that now. But now we've got spread, and it should be more of a circular spread that's uniform, I believe. So if I get my backpack and I start shooting, you can see that our bullets are spreading out very nicely. Now obviously when we do this gun system, we're going to have the client telling the server where our attachment is, so it's working properly. It's like if I'm moving around like this, it's going to be really weird for us to shoot. And also it's not pointing towards the mouse, which it should be. So we'll be introducing that. But apart from that, that's that implemented for the time being. Our test gun system implemented. To do was it ricochet slash reflection penetration, so called it penetration. So we'll do those two next after I go toilet. I think that was everything under the projectile service. Let me check. So bullet ricochet, bullet penetration, we've got the different values. So return a different value. Factors for penetration slash ricochet. I'm gonna put that under there. We'll add that there. I think that's good. That's good. Remove all that. Remove that. To do set up multi-vid. We don't actually need that anymore. We've already tested it. It's plenty of performance. I'm not gonna need any of that. Don't need that. So that's default. Don't worry about that. I'm actually gonna copy these notes here. Put a note there for that. There we go. And yeah, we'll do that next. I'll be back though. I need to go toilet break. Let me just push this to the framework. So here we've got, what was that, minus 123, 200, 200, 300, about nearly 400 lines there. That's pretty good. How long has, we've been up for 2 hours, okay. Yeah, we'll do a couple more things. So there we go, so we'll push that. Just so you can see what happens when you push it. under our GitHub post here. I'll get a stepping tool picture. We have it so it puts a embed from Discord about any pushes to the GitHub repo. Now this one's not public, so you can't access it, but you'll have the branch and the, actually this one's the branch over here, the second part, and then you'll have the information there. If I open it up in the web page, we can see the differences. So we've got 370 additions, 165 deletions, and it will tell you what the differences are. So yeah, that's pretty nice, for those that didn't know about that. And what I need to quickly do is take ISO of this tool. I just need that for testing purposes. I'm gonna wait for that to upload, and then I'll get to it. Once that works sometime. Eventually. Anyway. Yeah, so now we've got a geyser of this. And a geyser of this. I'll put these in the Discord if you do want to look at them. I don't know if the stream's got problems with viewing them, but yeah. Alright, I'll be back. I'll be another like 4 minutes. I'm just making coffee with marshmallows. Actually, to make an aesthetic, let me I'm gonna turn on the projectile preview. And I was AFK with the notepad up. I think that'll look cool for people joining in. There we go. Alright, so let's talk about the next bit. We have ricocheting, which is reflecting off surfaces, and we've got bullet penetration. So the first thing we'll need to do is find a function to reflect vectors off normal. So you have an incoming vector towards the surface. Let's say we have a part. So this is a ray of a bullet traveling. So we have this bullet coming towards the surface. We have the normal of the surface, which is like the up direction with respect to where this bullet landed. So at this point, the normal is this purple point. And we need to find the vector which reflects off that point there. In this case, I think it's that one. Oh, that's not the right angle. What angle is that on? Oh, there we go. So then our outgoing ray is the green one, our incoming one is the yellow one. So we need to find a function which takes this yellow one, transforms it to the green one given a vector. Now, I could try to do the math for it, I'm not going to bother. I'm going to go get it off deform. So, let's open up Google here. Let's do deform. And let's search for ray, well, let's say reflection. Reflection, let's do like ray reflection. Let's go filter. Rate for reflection, let's do scripting support, I reckon it'll be under. Yeah, so we've got bullets to ricochet, lasers to bounce. The angle... Okay, here we go. So our reflection vector is the... What is that? The incoming delta on that side. It's something. I know it's a semicircle and then you transform it over, but... So we have, let's see the pieces we've got here. If we go over to our projectile service, we have a job ID, which is reflection here, which is ricocheting. So here we can remove this is equal to 2, and we have our surface normal. So on our surface normal, that's from the raycast result. So let's do that. Raycast result normal. So that's our surface normal. Our reflected normal is our incoming direction, which is our velocity dot magnitude dot unit. A unit magnitude going into that normal. And we'll do some math, and we get a reflected one, which is the... If I bring these back. So our incoming one is yellow one. Our outgoing one is the green one. So now we've got the green one. What we can do... Oh, and the raycast normal here, that is this purple one. Do I need that twice? I do need that twice, okay. Local incident vector. So our incident vector going into that. Our reflected normal is that one, or our reflected vector. Or reflected direction, in our case. Reflected direction. These are directions, not velocities anymore, because we're at unit. Unit vector. So we get our reflected direction, and we multiply the magnitude by a reflection, let's say slowed down multiplier. So if I say reflection vector, or reflected vector, hey Wobtastic, is our reflected direction times our magnitude times by our multiplier, which is like how much energy is transferred from that when it hit the object, how much energy is transferred to the ground, or the whatever it hit. In our case, we're going to do 0.9, so that's 10% of the energy or velocity we had is gone to the object now, and we've lost 10% of our speed. So we'll do reflection speed loss multiplier is 0.9. Reflection loss multiplier is 0.9. So we can do that. That will go up here. So now our reflected velocity is our reflected direction times by our initial incoming speed times by our reflection loss multiplier. So now we've lost all the speed because we've hit the object and we're reflected. And we want to change our velocity now to match that. So self.velocity equals next velocity. Self.position is at the contact point of the surface. So now our position is at this point right in the middle here between the purple, yellow and green. Our velocity is the green line going out, so that's the way we're traveling now. And our yellow one was the one we were coming in with. And that's supposed to be that one. And now yeah, that's it. So now that we've got that, let's go and test it. And to test it, I'm going to go into our projectile preview. Actually, I'll do it with our gun system. Let's go to the gun system. I'm going to create a bullet projectile. And what I'm going to do with this is say data, set the on-ray hit function. And I'm going to say function. So return 3, 3 equals stop. But I want a counter. And we're going to say counter plus equals 1. If counter is smaller than 3, then return, is it 1? Is our 2. So 2 is our reflection. So it's going to bounce twice. So actually we're going to call this bounce counter. Our counter plus equals 1. Our counter, if our counter is smaller than 3, then bounce off the surface. Stop at this point. Like that. So we're going to have 3 bounces and then it'll stop. So if we play the game now, let's just spawn in. So if I get my gun and I shoot it, oh, it looks like it's just going through the ground. Can I shoot that more? I think it doesn't look like it's actually going to bounce. So let's have a look at why that's happening. Let's do task.wait 1 here. I'm going to disable the preview so I can actually read it. I might have to slightly push it off from the middle. I'll see what I mean by that. Okay, so it's exactly what I thought. So what's happening is the bullet hits the ground, it reflects it, but the position is in the ground still. So we need to slightly push it out of the ground so it doesn't say that it's hitting the ground anymore. So to do this, we're going to go self.position is the recast position, plus the reflected velocity dot unit, which actually in our case is the reflected direction, times by, let's say, actually we'll just plus it by that. We're going to move it, that's 1 unit off the surface. And also to help visualize this, let's do visualizer, attachment. Let's do it at the, let's actually just do it there. So we can see where we're coming in, going out. And we can see where we are beforehand. So we'll have our before, at the surface, and off the surface. If I shoot this, so you see it's actually bouncing a tiny bit, I believe. Yep, so we've got a little bit of bouncing. I don't know why that's not correcting itself anymore. Last position, step dot after position, after position. Let me print these. Set terminated function. Print. Terminated. That's weird, it shouldn't be terminating it on the spot. Kill projectile is true there, but not up here. Oh, was this 2? Maybe this 2 is ricochet. remove one. We need to figure out why that's not showing up properly. So that's before. Oh, the raycast is here. Okay, yep. Oh wait, no, sorry, it's in here. Create water projectile. Oh, because we do it on the server, not the client. Right. So what I need to do is actually take that and put that on the client as well. Okay, that makes more sense. Because remember, our server and client are two separate entities in this case. And to make sure they match, we're going to make sure we have the same options on both of them. But the problem was on the server, I had the reflecting, but on the client, I didn't, which was a problem. So now we can see that it's bouncing. That's pretty funny. Okay, now it's doing it, and what we can say is smaller or equal to 3. And then if I go back here, I'm gonna get rid of that terminated print. So that's all working. We've got bouncing now. And what I'm also gonna do is go projectile preview. I'm gonna say on ray hit, and let's get that previewer also going again. And I'm gonna make it 2 bounces, not 3. So now you can see that it's doing all these crazy bounces everywhere. Which is pretty cool. And all these attachments are like the in. You can see it's going into the point, and then it's bouncing off the point. And also if I do want to fix something else, which is if I go to the gun service. Oh, sorry, if I go to projectile service, when we bounce, we also get rid of the prints. It's bad to have there. When we bounce, we want to multiply our offset by delta time. So that way we're not moving one stud off the ground. We only want to move slightly off the ground. Otherwise, we're going to have a problem. So here, self-stop position is the raycast position plus the direction. We're going to apply that. We're going to multiply that by the delta time. Actually, I might not do that because it'll hit the ground, and if we do it that way, it might be inside an object, which will be a problem if we wanted to register hits. So by doing it this way, it'll be in the ground and then it will bounce out. So that way we'll make sure it hit objects. So it's not quite inside the object when it's on the surface, and it's pointing away from the surface anyhow. So it won't trigger a hit. Now, I'm seeing lots of attachments. I need to get rid of the attachments, which is under projectile service. I go up to the visualizer attachments, we can get rid of them. We don't need that one, so I don't need that in a variable anymore. Reflected direction, I'm going to keep that as a thing in there. With our normal, incident direction, reflected direction, and so on. So that's number 2. That's our reflecting off surfaces. And then here we have penetration. Okay. Penetration's a little bit harder to implement. I'll show you one. So you can actually see it's going really well. It's nice and smooth. And there's a lot of projectiles at that. Let's also increase the update speed and reduce the bounces. Oh, actually, let me reduce the speed which they're going at. Okay, there we go. Better. You can see all of these are nice. It's nice and smooth. And what we want to do, what we want to implement next is penetration. So how I'm going to test this is, let's say our angle of incidence is maybe let's have a cutoff. Let's do a cutoff configuration. So here we'll say local cutoff penetration angle. So let's say if you're at an angle of 70 going down. So if we put a part here, let's make it array. So if you're going at an angle of 70 like that. So let's say you're going, actually I might be a little bit well, it depends on the, how do I want this? It's up to the function anyway. So let's say you're coming in at a steep angle. Yep, okay, now I remember why. We need to do something else first. So let's say we have a part here which we're trying to penetrate. So this can be the wall. And let's say we have this ray. So we hit the ray at the very start here. We need to go through the wall to the other side. So that way we know our exit pointers. So this one will go to the other side. And that's our exit point. And we need the distance between these two. Now we need some function or some equation to tell us whether or not this bullet can penetrate the wall because of how deep it is. And you need to take into consideration the mass of the bullet, the velocity of the bullet. Well, not really the mass if you don't want to, but the velocity of the bullet is important, which is the speed of the bullet. So you need to see whether or not it's fast enough to penetrate that deep, and if it's heavy enough to penetrate that deep. In my case, I want to do that. Actually, I don't want mass, so it'll just be 1. So I only want to do it based on speed. So what I'm going to say is, okay, if the magnitude of the bullet is larger than, sorry, the speed of the bullet is larger than the distance between the 2 points times by 3. So if these two subtract each other, 41, let's see, let's do print 41.45, 42.95. So if our magnitude is larger than 1.5 times 3, we can penetrate this wall. Let's say that's my equation that I come up with in my head. So if our bullet is going 4.5, whatever studs a second speed, it can penetrate this wall, and we're going to lose a certain amount of velocity, which we can also set. Actually, I think that might be better. We'll have it so you return whether or not it can penetrate the wall, and we'll also make it so you can return the new velocity of the bullet, or the new speed of the bullet. So in this case, since it's 4.5 is the required magnitude to go through the wall, I'm going to say, okay, to get through the wall, I'm going to do 1 over 4.5. So every time this value goes up, this multiplier gets smaller. And we're going to do the magnitude times by that. So in this case, its output speed will be 1. Let me actually make this local velocity equals 4.5. So let's say the required is at 1 divided velocity, and let's do like would be velocity times 1 velocity, maybe. Five, 10. I'm just trying to figure out a formula I can use here. Divided by velocity times. Oh, yeah, that makes sense. So as velocity increases, I need it. So 1 over velocity, the distance. So dist equals 4. So let's say the wall thickness is that. I want the opposite effect though. So 1 minus that. If I did 1 over this. I mean, that works. So, the required velocity to penetrate a wall that is 4 studs long is 12 studs a second. And the speed that you get out of exiting the wall, if you're going 25, is 6.25. So we can do things like that to determine how much speed you get. And then, let's say we can have like maybe 1.25 there. If our velocity is 4, that won't penetrate. 8, that won't penetrate. 12, that will penetrate. 15, penetrate. And as we go up... No, that's still way too small. I need to figure out a different formula, but I'll figure that later. But as we go up, this should get closer and closer towards this velocity value. Because super high velocity items will just go straight through the wall. It won't lose much speed because it's just going to shred it. But as they get slower and slower and slower, it will make more contact with the wall, more friction, and it will slow it down more. So that's why I'm trying to use like 1.25 over the distance it has to travel. But anyhow, we don't actually need this cutoff penetration angle. That will be determined by the function, whether or not we penetrate the wall. Here, let's add the penetrate function. What we're going to do is find the exit point of part. So exit point of the... Alright, I'll do exit point of instance, which will be done through a function. So we'll do find array exit point. We're going to have the start, the direction, the target instance, and it will tell us where it exits in that instance. Exit point of instance, and we'll get the distance as well. And then, as before, we've got our formula here, so we'll do local penetrate. After velocity. We'll just follow along this for the moment. We can actually have a function for that. So self on penetrate calculation. We'll do our velocity. And distance, maybe? Yeah, velocity and distance. I think that should be good. We could do something like, so let's say this is the object, so it comes in. We could have a little bit of a random, so it may go slightly up and out, or it may slightly go down and out. We can use that, in the gun service here, we can use this spread angle thing. But for now, I'm just gonna have it so it goes straight through the middle, wherever it came in, and it exits out that side as well. I'm just trying to think how I want this. So, find ray exit points from instance. Let's get this function implemented. So how this function works is essentially start direction target instance. What we want to have is a part. Let's actually get this example here. So let's say our array starts here and we're going into the wall. How we do this function is to support all shapes. We're going to raycast into the wall by a certain, it's called a epsilon value, which is like how fine the value is before it'll like stop at that point. So we'll use an epsilon step to say, okay, let's say we step in 0.1 studs, we raycast backwards. We step in again, 0.1 studs, raycast backwards. Step in again, raycast backwards. We keep doing that till we get outside the wall. Once we're outside the wall, we raycast back and get that position. Now, it's probably better. Let's do like exit point ray epsilon length. So this should be something pretty small. As if depending on the environment you're doing it in, like if you've got several walls like this, if you have large values, you may have the ray step out here, and then it will actually get this wall, not this one, which is a problem. So you want smaller, finer values, so that way you can get into this second part and raycast backwards that way and hit this wall, which is one it actually penetrated first. And then when that happens, you'll exit the wall in the middle here. So you'll exit there, and then you keep stepping forward. I don't know if I'm explaining it properly, but you keep stepping forward and you raycast backwards, and then you found that you exited this object out of this position, and then that object's being penetrated as well, and then you keep doing the raycast after that, out that way. Well, okay. Now, I have implemented this, so I'm going to grab that because it was a pain in the ass to implement. I'm going to go to my... I don't even remember what it was under. I think it was light fraction. Yeah. Raycasting smart. Except I get that error. Okay. Give me a second. Let me open up a new base plate. Roblox, stored projects, light tracing, raycast smart. Let me open up that file, raycasting smart. Don't worry about the other shenanigans here, I was just testing Snell's law. But what we have here is a raycast, and we have a recursive raycast backwards. So this function here will find the exit point of leaving an object that you have intersected with. And this can also be models that it intersected with, so... Yes, like this one you can have models of it. So here, I'm probably not going to use that. So here we've got our resolution, which is how many studs we take every step. So in this case, I take 0.3 of a stud. And then this is how far maximum it will check. before it's saying it's not penetratable, or there's no exit point. That's actually for both of these, they're the same. I don't know why that's there. But yeah, so we can find the exit point, or there's no exit point, shake too large. And then that's recursive recast there. Alright, so for this, I don't need actually any of this, any visualizers. So let me get rid of the visualizers. Let me get rid of that assertion. We can get origin, recast result. Just making sure I don't have any unwanted things that I don't need. Hit material, don't need. Hit normal, don't need. Hit position, need. Hit instance, need. And yeah. And this actually returns all of the objects that penetrated at that time. So actually, I really only want that one. Okay. That's not needed. That's not needed. Origin, direction, or default params. Give me a second, just click these out. Or default params. Let's make sure I'm not using that weird function. This is old code, that's why I'm looking over it. Don't need that. That can go up there. That's fine. Fine. It's just distance. Is that even being used? Nope. No. Don't need that. Okay. That's fine. I can use that now. So here, actually, for this one, that would be this function. So I have the start. We've got the target instance, we've got the direction, and we've got the default recast params. So yeah, I'm actually going to keep these. Epsilon, negative ray, epsilon length. And we'll have local max negative ray threshold, and that'll be 30 studs. I should make that 20. Oh, 30 studs is around. And that's pretty much it. So that will return either false or a recast param. Direction. Direction equals direction dot unit. I'll keep that, and I'll say that's length. This one is the raycast result dot position minus start dot magnitude. This one's the exit position. So now we have the exit position, exit position, distance. The start is the before. The direction is before. Target instance is the raycast dot instance, raycast result dot instance. Our velocity is the before velocity. Our distance is a distance. So on penetrate calculation, let's make a function for that. Oh, we'll do a can penetrate function. We'll do if can penetrate then, else self-destroy. Yeah, let's do self-velocity is none. That will be the raycast position, where we hit the wall. Otherwise, if we can penetrate, the position is at the wall. So that is the exit position. Our velocity is the after velocity. And I think that's really it we need to do. So that's bullet penetration there. Let's do a function for that. Function base projectile class can penetrate calculation. We'll have the incoming velocity, and we'll have the distance. So we'll have our incoming velocity magnitude. We'll times it by our penetration loss calculator, or the value that we lose from penetration. If we can make it out with that loss, then we've exited. Otherwise, if we're stuck inside the wall, I think that's pretty good. So we need 10% of our velocity to get through the wall, but we need enough velocity to actually penetrate through the wall. So in this case, I might make it so our penetration loss multiplier is actually let's say, I want to say incoming velocity dot magnitude divide by distance. And we'll do math.clamp that value between 0 and 1. And we'll have distance times... Yeah, we'll do distance. So what we're saying here is, let's say our wall is 10 studs thick and our incoming magnitude is 20. That will give us a value of 2 if we divide it like that, which will clamp to 1. So 1 means we will make it through the wall as we lose no velocity. No, that's not a good idea. Because that means we lose no speed, but we should lose speed because we're penetrating through a wall. Penetration loss was probably 0.99. Let's do... You know what, let's just do it like that. Let's do simple penetration loss multiplier. If it's not fast enough and can't make it through the wall, then I will. So if it's larger than the distance, then it can penetrate the wall. unless I clamp it, so... Yeah, I got it now. So we need a minimum, math dot clamp. It would be incoming velocity dot magnitude divided by the distance. It would be a minimum of 0 and a maximum of 0.8 of your original speed. So even if you're going super fast, you'll lose 20% of your speed trying to get through that wall. Or actually, it can be like 90. You can lose 10% of your total speed just penetrating through one wall. No, I should do 5% loss for every wall. That makes more sense. Something like that. Okay, I'm picking and choosing stuff here. So then we'll say, okay, between 0 and 1, how much of that do we lose? What's our penetration velocity? So how fast are we traveling through the wall? Or penetration cost. Yeah, that's correct, yeah. So that was correct. Let's do it right. That's penetration velocity. So that's pretty much our velocity after exiting the wall. And that is whether or not we have enough velocity to even escape the wall. Okay. I got it. Let's go back to our studio. Not this one. This one. Let's make our gun penetrate rather than bounce. So it would be 1 for penetrate. So let me do this. And turn 1. And then what we can do is set up a bunch of walls. So if I do that. And what we can actually do is a pretty neat thing. We can have... So let's say we've got this many walls. We'll start with thin walls. We'll get slowly thicker, thicker, and thicker. Like that. And then if I get building tools, I can just expand it out that way. Okay. Now with that, let's check it out and test it. I think I did that right. We'll find out. So if I get my backpack again, to get past all this other crap. Oh. Looks like that's a no bueno. Let's see why. Also, let's disable that. So if 2... So let's reflect. If 1, which we do have it set to here. Find exit ray from instance. So I guess that's just doing it infinitely then. Well, not ray result. That's 30 studs. That's what, 200 times we'll do it? If it is destroyed, do that. On Boolean and vector 3. Boolean and vector 3. What? Boolean and vector 3. That's interesting. Exit position. Oh, that can... okay. If not, exit position, then self-destroy return. If can penetrate, otherwise not, stop it there. So actually, let's do exit position and that. Yeah, here we'll just have to do just have to do it this way. Yep, ray pass backwards, get the distance from that. Okay, that should work. Self-top velocity, self-top position, delta time. Self-top position. Yeah, that'd be the problem. Yeah, there we go. So if there is no exit position, then we can't penetrate, so just keep it false. Which is by default, okay. I think that should fix it. Dot backpack through. Maybe? Oh, that went really high. Oh, is it set to bouncing still? Gun service, return 1. 1 is find exit points. Return 1. Huh. Weird. Oh, yeah. I did it again. In our gun service, we do return 1. In our projectile service, we need to do return 1. Okay, there we go. Now if I try that again, we can see it's traveling through it. I'm going to slow down time so we can actually run to the side and see it. So if I do, let's do our client side render. Let's do projectile service dot set global timescale 0.05 or 0.1 maybe. Let's do that. Let's set our max to 100 so I can zoom out really far. Now let's shoot the bullet. We can see it's going through, looks like all of them. Okay, so let's see, let's see how much of the velocity we lose from going through the wall. I think that's probably what we need to check. Who's up? Yeah. So if we go to our projectile service, let's go to the penetration one here. Let's find where it's called. So let's do print before velocity. And we've got after velocity, so we want to see what the difference is between these two velocities. And then with that number, we can say, okay, do we need to increase or decrease the amount of speed you lose? So if we do that, if I shoot, oh, it broke again, okay. Oh, I know why that's also erroring now. So here we can actually see, we get 5, then we get 4.5, 4.1. So it is actually reducing the speed, but not by much. So what we can do is say, okay, that is not low enough. Let's do like 0.7. So we lose 30% of our speed every time it goes through a wall. Or do like 8. And here we can also do like every thud actually removes 1.5 times the velocity. I'll put that as A5. Also, to fix this issue here where we freeze, because we error every time we update, it's going to break it. So what we need to do is go to our projectile service, scroll all the way down. Let's find the run service update. And what we need to say is, if not updating, then update it. So here we actually do an oopsie. We want to move that to a new line and move that one there. So only if it's not updating, we'll update it. And then because this isn't removing it, we need to increment here. If we keep it like this, when that projectile is updating, or if it's errored, that will always be false. So it will never increment the index here, which is a problem, and it will crash it. So we need to do that to make sure it increments. And we want to move that to a new line, so that will work properly. So now that issue is fixed, and we shouldn't get that anymore. We'll only get the error. In this case, we probably also want to remove the error projectile from the system. We can do that in a moment. And make it optional. So here you can see, let's see how far it goes. So it actually goes through all of them. Let me just make it so, if we do, actually I'll keep the error one in there, because it will just stop there. Or projectile class. Errored. Here we'll do errored equals true, errored equals false. So this way we say, okay, have we errored? If so, oh wait, no, that wouldn't be a good idea, would it? We should do it at each one of these. That's better. So less chance that this will kick it out for no reason. We'll see. But essentially, we'll set error to true, we'll update. If this errors, it won't set it to false, which will mean the next time this one runs up here, it will kick it out of the system. Apart from that, let's get that print back so we can see how much velocity we lose. So here we'll do print after velocity dot magnitude minus the before velocity dot magnitude, and we'll play that. So we shoot that. So we get -7, -7, -6, -5. So we slowly but surely go down. 159 is erroring. Index boolean with that. Okay, so what we want to do is say if we can penetrate, then print it. Otherwise it will stop. Hey Danodo. Yeah, site owner. Okay. Now that we've got that, let's also add a few more of these ones. And then let's squish them together. So I'll do very finely here. What I'm gonna have is attachment spawn to where it's destroyed now. So we can see where it ended. Do you need anti-clip scope? No. No thanks. I'll be doing that later. I'm gonna do the anti-exploit. Okay, so we penetrate the wall. They'll slowly decrease. When we destroy, or when the bullet gets destroyed, we want to spawn an attachment. So on the projectile service, let's scroll down. On terminated, we destroy them, but we also want to do visualize. Yeah, anti-cheats are pretty fun to make. We'll do an attachment there. We'll do it at the projectile data. Oh, actually, this should be self here. Put it at self dot position, and we'll put it there for like 5 seconds, 4 seconds. If we go back in game, yeah, I do have to implement that too, Dano. Like time and no clipping and remote spamming as well. No combinator. So here, if we look at the projectile, so some are actually slowing down really fast. So if you look, so if I stand here and do it, you see it goes way past the wall. But if we come here, it gets slowed down through these walls because it's got to penetrate it. And what we can also do is have a material multiplier. So if we scroll up and we go, where is it? Let's do a material multiplier. I'm going to move that actually up to the top here. So we've got reflection loss, we've got threshold, we've got step iterations. We also need that penetration loss multiplier. So here, I'm going to change this multiplier to a material matrix. Penetration cost matrix. So what we want is like things like enum, the material, metal. So metal will have like a very high value. Material multiplier. So we'll have that there. So that requires 3 studs a second, or actually we'll make it like 5 studs a second of speed to penetrate through 1 stud of it. So that's what that means there. Childano. I know how it works. So wood will require 1 velocity, or 1 stud a second to penetrate 1 stud of wood. For plastic, we can have a smaller value than that. We can do like, okay, you need 0.25 to penetrate that. And then we can have a default value, which is just 1. And then we can take that to the top. We'll put that there. So now this function takes in a material multiplier, which we'll do here, material multiplier. And to get that material multiplier, we'll do material multiplier equals the raycast material name or the default value. And once we get that, we can use that in there. And actually, we could optimize it and put it in there too. And there we go. Now we can say, actually now we can see what the difference is when we try penetrate metal objects. And what we can do, or what we can see when we try penetrate wood objects. So if I scroll back up now, so plastic, actually that probably isn't a good idea. Does that? Okay, yeah, that does do nothing. So pretty much plastic, you only lose 0.25 of the... So you only lose 25% studs per second per stud. So you lose 0.25 studs a second for every stud. Wood, you lose 1 stud a second for every stud. For metal, you lose 5 studs a second for every stud of material. And then defaults, you just lose 1. I don't know if you're still trying to sell me your anti-cheat, but I don't want it. Here, let's zoom out. So that one's sort of doing it normally. I think it's shooting... Oh, no, it's going through it. So you can see it's reaching quite far. And then let's go to the wood one. So if we go to the wood one here, you can see it's actually a lot shorter. It's not reaching as far. Actually, what I'll do is get rid of the spread so we can test this properly. Let's just do the dot look vector. Let's do that again. So this should be straight now. Yeah, there we go. That's better. Let's set our max zoom to 100. So we shoot that. If I stand right against the wall, you can see it reaches quite far out. So that can get quite far. If we come over to the wood one, it should be a lot shorter than that. Maybe not. Anyway, the middle one should definitely be doing something. Okay, so it looks like it's actually not changing it. Let's go back to the projectile service. Let's go get the matrix cost. So let's do the before minus the after. Maybe if I put a platform, it'll be easier to see the difference. Because I'm jumping a lot. Let me move that out here. So we have a platform, we can keep it constant. Let's do that. Maybe that'll be better. They also get rid of plus shadow. We don't need shadows on that. Right now I'm doing a gun framework system. So this one's a projectile handler, and then that's linked to the gun framework. So if I shoot there, oh, that looks like it's actually doing something now. Let's see how far that goes. So that reaches just before the last one. Actually, I need to do a fair test. Let me, if I do that and I stand there, it should be good. Yeah. Okay, so if I stand there, oh, it doesn't. Let's get as close as I can. Okay, so I'm like slightly leveled. So that should be reaching, yeah, pretty much the last one there. So that's reaching pretty much the last one. I need to make it so it leaves what triggers the one hit. That one's reaching the last one. That one's also reaching the last one. Okay, it's not doing it properly. What's this saying? 2.9, 2.6, 2.3. It's not losing it fast enough. Let's see, so loss multiplier. I need some way to say... Oh, let's have a base velocity to penetrate a material. Like, we'll min velocity to penetrate material. So you need a minimum velocity of, let's say, 3. And then we can say, okay, that plus that. Plus equals a minimum. That doesn't seem right though. So the incoming unit, you get the length of it, times it by the loss. And then that's how fast it is, and then that's the new penetration velocity after you've applied the loss. Let me print the loss. I need to do that. Also, let me make this like local last fire equals tick. If tick minus last fire is larger than 1, then oh, it's smaller than 1. We'll just continue. No, we don't. If it is larger than 1, last fire equals tick. Otherwise, we're going to have a crash problem again. So only if it's fired. Yep, okay. And we'll do 3 seconds. Oh, we'll do 2 seconds. Maybe sunset cods, nice. No, it sits on the bottom of the desktop. How do I get length for what? Reading model, I have a bunch of calculations. It does even like see for such command studs. Yeah. Nice. Zero 0.9. 0.9. 0.9. Okay, so that's constant. That's not changing, which is a problem. So what we need to do is print this one and see what this value is. Okay, penetration cost. Or initial penetration cost. Penetration cost clamped. And then what we can do is print the initial and print the clamped. Okay, let me, if run service is client, then print it. Let's check if it's client. If it's on the client side, then we'll print it. So that way not mixed with the server. Okay. Oh. Let me also go here and back inside there. Okay, so we're 217, 171, 216, 96, 215, 130. Okay, something abnormal is going on here. Let's see. So what should it be? So initial cost is 215. So that magnitude is becoming smaller than 1. 10 divided by distance times that. Would it be that? Is that the solution for it? Because if you're dividing by decimal, it actually multiplies it by 1 over the decimal value. Quick math. If we do it that way, 235, 115, 156, 115. I need to see. That one, that one, that one. That one. And let's read this. So we have the distance being a decimal value. Okay, so that's the problem. So if distance is smaller than 1, then else. So if distance is smaller than 1, then that is going to have to be done. If distance is smaller than 1, we'll divide it. So I open up the calculator, 0.05 divided by, so 0.2 divided by 1. 1 over 0.5. So that's correct. And then if our initial, or if our distance is larger than 1, so let's say 3.2 times 5 And we'll say 1 over 16. And then we'll times that by 50. Okay, yeah. And then that's clamping it. Unless I map it. No, I'll just do that. Believe it. Might be opposite. We'll see. So what we should see is it decreasing. So here we've got 50, 45, 40, 33, 29, 27, 24, 22, 21, 20. So it's decreasing now, which is good. So if I get rid of this first sprint, is it first sprint? Initial costs. So we've got 4,000, 1,000, 1,000, 1,800. So that's extremely high still. So, oh, I was reading it wrong, sorry. 0.04, 0.09, 0.08, 3.8, 5, 5, 2, 4, 4, 4, 4, 4. What's 4? So 4 is a material multiplier. 3, 5, 5, 2, 40, 2, 2, 2, 6. Need a different equation for this. How don't we just do simple that times the imperial multiplier times by the distance? So if distance is smaller than 1, we don't want to divide it. Otherwise we'll divide it by 1. So that way that decreases it, that decreases it, and that's on clamping it. Honestly, I don't know what I'm doing. I'm just trying to figure out something that makes sense of it. Okay. That definitely... Is that working now? Let's see. So we have 3, 14... Hold on, let me, So let's do initial penetration cost. So that's how much magnitude it costs to... I do need to map it now I think about it. Okay. So it should be 6, 13, 15, 10, 7, 10, 8, 6, 4. How much does this one? Does that go through all the way? Because it flips. I need an Excel sheet. Let me get an Excel sheet. I need to figure out an equation for this. So it's got to be dependent on the incoming magnitude. So, oh fuck, I forgot how bright it was. Okay, so we have velocity. We have the wall thickness. Oh, yeah, wall distance. And we'll have a material multiplier. So bullet velocity, let's start with like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 0. The wall distance, that will be, let's start with 0.1, 0.2, Actually, 0.25, 0.5, 0.75, 1, 1.5, 2, 2.5, 3, 4, 5, 6, 7, 8. And the material multiplier, that will be a constant. So in our case, let's just do 1 for now. So as the wall distance gets larger, and as the bullet velocity gets smaller, which I might flip it. Is there an easy way to flip this? Can I flip? Sort. Nice sort. Sort smallest to largest. Hey, there we go. 0 to 10. So as it speeds up and as the wall gets thicker. No, wait, no, it should be the other way around. As it slows down, we should have downward graph. Yeah. Okay, so our equation currently is, let me move this over here so I can read it. So we have our incoming magnitude. Oh no, that should be there. What would it be? How is this done again? Or is that supposed to be up there? That's supposed to be up there. That one goes up to the side. Yeah, there we go. That's what I wanted. Okay. That is the wall distance. And that is the bullet velocity. Which needs to go down one. Yeah, I'm triggered, whatever. And then these are the values. Which will what you want. Okay, so as the wall distance, so let's do equals the incoming magnitude times by the material multiplier times the distance. So that one times by that one. So this one's going to be locked. The material multiplier is constant for all of them. In this case, we want to lock the... As we go that way, it will use E, F. We want to lock the number. And for this one, we want to lock the letter. Okay. Yeah, and if I use autofill on that. Oh, I'll just do it by hand. And this is the output velocity. No, that's the cost of it. Okay. Maybe we should have a base value. The base value is 5. It would be 5 plus 5. Which is 5. So that would be plus that one, which is perma-locked. Now to fix all of these. So all of these will require at least 5 magnitude to break through them. And as you get faster, it should cost less to break through the wall. Which it doesn't. So to make it, the red is that one. So it would be, if I do 1 over that. Bullet velocity, that's out velocity, so that shouldn't be increased. That should be... Was that D? No, 6. Let me move that back. So the wall distance is 0.1. As you get slower, it costs. See, that's the out distance, so that should be happening. So it should have been 1 divided by that. See, that's correct, but the problem is, as the wall becomes a decimal value, or as it becomes 1, it's higher than the original value. So if it's smaller than 1, or if it's equal to 1, no, that doesn't make sense. No. Well, if I say the bullet velocity is... If I clamp it to the velocity of the bullet, that's like a super easy fix. Clamp it and minus the base cost. So what I mean by that is use this normal formula that we've got here. And we'll just say, okay, if the value is larger than the initial bullet cost, then set it to that and minus 0.95 worth. That sounds better. Okay, let's do that. So I won't need that. Oh no, yes I will. Oh wait, no I won't. So what I want is, it'll be 0.95 worth. Yeah. So initial penetration cost is what formula? The 1 over material 1. So this one. And then what we'll do is clamp it between 0 and the incoming velocity dot magnitude. And then if it's equal to the incoming velocity dot magnitude, we'll times equals it by 0.95, 5% of energy. And then we'll print that. I think that should be better. So then as our multiplier changes, yeah, let's do if is larger than that one. So C7 block the C, then that one times 0.95, otherwise it's that one that we just had. I don't know how to use variables, so I'm not going to bother. That's starting to make sense. Okay. And then that material multiplier is also part of the base cost. So that's 4. Oh, 8. Oh no, that's not working I want. And if I some base cost. No greens. Zero. You can't divide by 0, so it's gonna be 1 by default. Or if that's larger than that one, why is that not? Oh, because it's 1 divided by 1, right? Oh my god, this is wild. Okay. Divided by 1. Larger or equal to. Larger or equal to. Okay, that's the solution. It's 1. That does not make sense. Is larger or equal to. That makes more sense. Otherwise, I do it by wall distance. 1 over wall distance. Divided by 0. Was that H6 or locked on the 6? And that's collapsed. No, that doesn't make it better. If I did that. No. 1 minus 1 plus that. When it's 1, it should be 7. How do I do that? 1 minus that. If it's 1, it can't be that. Eight. 1.9. Oh, I got it. There we go. Let's go. 1.5. Okay, that's what I want to do. From 6. Oh shit, it didn't actually lock it. Was that row 6? Okay, yep, there we go. And then I just say if is there a 0? Can I just say or 1? Oh, I can just run the code. Okay, let's implement it that way. Right. Let's do that. So if the C7, so if the bullet velocity dot magnitude times by 1 divided by the d6, the wall distance, times by the material multiplier, is larger or equal to that incoming, we want to return incoming magnitude minus 1.5 plus the distance. Else, we're going to set it to that. Initial penetration cost equals that one times 1 divided by distance times that. Okay. So then what we can do is put this in a variable. Local material thickness multiplier. Okay. And then we want to clamp that so it's above 0. The initial between 0 and the incoming magnitude, just to be sure. And then we do none of that, none of that. Print that. And it will be the magnitude times that value. Oh no, sorry, that is the magnitude, so that would be that. Velocity after penetration cost. Thank God we have an Excel sheet. God damn. I just need to make sure that... Yeah, so as material goes up, you get less and less speed. Okay. And I could round it actually. Round that to 2 digits. And then... a special... Is that linked? Okay, that's linked. So then what I want to do with these is say... I want to... If that is smaller than 0, 0, D7. Okay, there we go. And then I can put that in a graph. So if we get a graph, we select data, we say the values of this oh wait, no, we need to do single rows. That is the wall distance. And then these ones are the velocity, I think. 10 is 8.4. Yep, so that's correct. And then we can do that for each of them. So you can see as the velocity decreases, you get a different curve. Let me actually do that again. That one. That's bullet velocity. Wait, there is a bounce. Oh shit, I didn't realize that. Ah, back to the drawing board. What's that bounce? 1.5. Oh, right, yeah. So that's 1.5. Let's see if that fixes the graph. Oh, that fixes it, okay. The majority. And it did the correct data range. Okay, I did. At 1. Oh. I need to check. If what? If that. That's fine. It's this one. So if that's larger than 1, I didn't think about that. So that one should be math.clamp, that value between 0 and 1. Okay, that should fix it. I really wish I could use variables. I don't know how to use variables in Excel. Which is unfortunate. I think applying that logic though should fix it. Okay, let's play here, test it. So as if it's traveling through the material, it should get slower, which that one is. If I go to metal, it should definitely get a lot slower. Okay, so that's actually a little bit faster. So let's have a look what it looks like when I increase that to 5. So at 10, it's pretty much the same as you go down. Okay, so it needs to be way bigger. So in projectile service, I do like... Yeah, I'm gonna have to... let me get rid of this base one. So default, I'll do 20. Wait, no, I have to do 10. So 10 is... That's pretty much the same, yeah. 12 even? 11? So I do 11 default. Metal should be 20. Wood would be 12. Plastic would be 10. Well, plastic can be like 7. What if I do like wall depth? Oh no, I already got that. And so just clamp it so the wall has to be larger than 1. Nah, that'd be annoying. I don't want that. Okay, so we've got 48 to 34. 35. 34. It's not right, is it? Let's see what the multiplier is. I don't know if it's giving me the right one. 11. It's also 11. Also 11. 11's default, isn't it? Wood. Oh, I used the name, not the material. Oh, duh. That's why it's not working. Metal. Wood. Actually, I'll do it the enum.material where. I don't know why it's not actually getting the right one. Oh my god. It's been a long stream. Let's get the... So instead of raycast material name, we just want to use the material enum itself. Otherwise, use the default key. Give me something. If I do that, now we're getting wood, so that goes to 32, and then we get metal. That definitely worked. Holy gosh. That's down to 8. That's at 33. 34, 33. 25. 25. Yeah, that's God damn. I wonder why there's a difference in stuff. Weird. Oh well. Now that's done, what we need to do is kill the projectile. So that's actually what we need to do here, rather than destroying it. Yep, so that's ending there. That's ending in there. Lots of addition, bullet penetration. There's bullet ricocheting. How the fuck you spell that? Ricocheting. Correction in. Oh, actually, I think it is this other thing here. Let me get rid of that. Yeah, I think we should just leave it in there, I guess. In, there you go. Oh, we did a lot of code. God damn. Oops. Heck. There is spread on this, isn't there? There isn't. Okay. Oh, it's the animation. That's what it is. Yeah, let me try and delete the animate script for that. Okay, now it's not moving. Oh shit, now it's facing downwards. Hold on, let me. Oh fuck, that's not gonna work. Hold on, let me respawn, delete the script, and then change the pivot. And hopefully that'll work. Oh, and also let me get the... If none of these new, this menu's here. This menu's pretty sick. One thing you should get is the orientation indicator. Add that there. You can click it up in the top left now. So if you click it apart, you can see which way is the front surface and which way is pointing up, which is pretty helpful. Now Valfix. A Valfix. Val for Valfix. Oh, Jesus. But yeah, so doing that, we can actually see which way our tool's facing when we're trying to rotate it and shit. So we jump in game here. Let's get our backpack. So right now it's shooting downwards. Oh, no, because of our animations, it's shooting the right way. Delete the animate script. Oh, no, now it's shooting it the right way. Don't have to worry about that. But yeah, so we've got... It's pretty constant. maybe? It's a few off, but if I go here and do it, I have a feeling it just it jumped and reflected off them. This one's a little bit weird. Okay, what are we at? That's 0.1 stars. Let's do 0.05. Let's do 4-step iterations. Try that. Let's try that. Oh, what did I change again? Step iterations, okay. So I'm just trying to see if I can make it not bug out as much. So like if I go here. So that goes to 34. That goes to 34. That goes to 34. Hey. Yeah, I need a better way of doing this. I'm just gonna I'm gonna make a part here that does it for me. I can move around. That's gonna be so much better. Get our preview. Class.defer function. So instead of this here, let's do it in here. Local shooter parts. Workspace, wait for child, shoot. Shoot heart.cframe. 1 through do, task.wait 2. Okay, there we go, that's better. So 30, 36. Okay. So that's step iterations 4. Let's go step iterations 2. I'm gonna automate this real quick. Hold on. Let me main menu. Let me just make this invoke server. Name class B. Oh, there we go. It's better. So 34. So what we changed then was the step iterations. So that's reaching 25, 30, 27, 26. Okay, let's change that to 8. $28. Okay. Oh, I just realized. When you go back and, we need to increment time. So when we exit here, we actually we can jump an entire large part's distance. So what we need to do is increment time at a pace that, so like here we'll do self.time elapsed plus equals the distance, times of distance divided by velocity times by delta time. Wait, no, that's, yeah, distance divided by velocity. Because it takes time to travel through the wall. So, we need to make sure we do that as well. That being said, I do need some delay time. So we need to delay this projectile a little bit, but we're also going to elapse the time. So let me add this delay time here. Let's do... Actually, this is better. Let's clean that out. Let's get this delay time. So time elapsed is larger than that. If self.delay time is larger than 0, then self.delay time minus equals delta time. If self.delay time is still larger than 0, then return. So that's saying, okay, we're going to delay the projectile a little bit. There we go. What I'm noticing is... Well, gravity is also helping, that's why. Let me remove gravity. I think I need to do that. Let me set the global acceleration. Is that a function? Yep. So let's go projectile preview. Let's do projectile service, set global acceleration, vector 3W. And then we can actually see what it's doing without gravity playing a part. So that's going to 25 or 24, 22, 31. Now let's move it here. Yep, okay, that's definitely working now. And then we do this one, that's just going straight through. Perfect. Okay. Let's add spread back to our gun tool. Maybe. Oh wait, that's something else, yeah. Okay, so that's bullet penetration. That's also bouncing, which we can do some neat stuff with. So if I grab this example again, and we do something like this. I grab that. I go here and I point it at that one. So that's gonna hit there, that'll bounce there, that'll go Plinko style. I reckon. Maybe. Oh, I should have it like that. Yeah, hold on, I'm gonna do it like that. If we do it this way, it can bounce as many times as it wants, and it won't be able to escape from this. Like that. To there. Okay. Now we have this little playpen. We can see it spamming jumps everywhere, which is something I wanted to do while we're doing this. So if I go back to our projectile preview, I'm going to swap these so this one's active and this one's deactivated. And now if I play here, oh. Let me aim for these. Let me actually do shooter parts. Part. Wait, no, that's not. So shoot apart one C-frame. Shoot apart two C-frame. Let's do one there. Let's do two there. So two is this one, right? Yeah, shoot two. So shoot one's the one up top. We want shoot one, position, look vector. Shoot one is up there, so that one's going to be the bouncing one. So we want that here. So data 2. Let's go number 2, number 2. And then data 1, data 1. So that is penetration test. That is bouncing test. And we can do that. And I think I did that right. No. Other way around. Data 1 is one up there. Okay. And shall I just swap the names of these? That's 1. And that's 2. And if I go shift P, we should be able to see this one. Not bouncing because I removed gravity. So let's do data 1. So that's penetration testing, so we can actually disable the print for that now. Let's disable that print. Let's go preview. So we've got penetration testing, that's fine. This bouncing one, however, we want gravity. So I'm going to do set acceleration, vector3.new 0, workspace.gravity, just minus that, I'm 0.025, something like that. That, my bad, let me fix that. So that's set global to nothing, so the penetration one is just moving forward, and then this one can use the local gravity of the world's gravity. So that one's doing normal penetration testing, this one should be bouncing over the wall. Let's do times 20. Oh, that. And we'll times that by math.random as well. Let's see what that does. Wait, no, that's not gonna work, is it? Maybe? Oh, no, yes, the velocity, so it should be fine. Oh, and the lifetime we need to increase. I'm gonna do like 15 seconds maybe. And I'm gonna increase the rate. Let's do 1. Do I want this to move? Yeah, I kinda want it to move. Maybe I should just do... Let me do a function module, bouncy projectile test, shoot to C frame. So shoot to C frame, so I can do that. And I can do function module penetration projectile test with the shooter C frame. There we go. So then we'll have, let me actually make this shooter 1, 2, 3. And that can be 4 then. So shooter 4. I'll shoot 4. That'll be 1, 2, 3. There we go. That was a fair bit to do, but now it's done. So now we get these testing ones. Yep, and if we go Control P, we should see that is auto penetration testing. I want bouncing testing. So I'm gonna add 2 here. Let me move this one. I'm gonna flip it along the whatever axis. Put it that way. So that would be shooter 5. There we go. Yeah, so at this point I just give it a C-frame and it'll do everything else for me. And I can set up a on-hit function to check for a humanoid. And yeah, that sort of stuff. There we go. Now we've got like a plinko system, we've got bullet penetration. Pretty cool, if I say so myself. Uh, 119. Let me also clear this one. Now what we can also do is make it so when it bounces off something, we can reduce the energy it has left from the bounce. So if we go to reflection here, we've got a loss multiplier, so we actually need to reduce this one now a little bit more. Also that's fine, that's fine. Glow acceleration, fine, that's fine, that's... I'm gonna reduce this back to 4. Oh, let me see what it says. What the hell? Yeah. We do have all these projectiles here now, and this one's a little bouncing there. So you can see now that when it hits something, it loses a lot of its momentum. So, and then gravity plays a part in bringing it down the plinko. And if we have a look over here, I think we might need to increase. Let's do another check here. We had a minimum required amount to pass through the object, but I don't think it's actually doing that minimum amount. So if that times that is larger or equal to that, let me check the magnitude of this. Wait, no, that does slow down. That's correct. But if it's... If smaller than the material friction multiplier... Oh, no, not material. Material multiplier, then... That's equal to 0, else we'll clamp it. So once it reaches a slow enough speed where it can't penetrate the material, it will just stop. So like this metal one, was that 2? Yeah, so it only can get through a couple of them. This one, it just goes straight through. So that's good. It actually looks like I might need to increment that again. Okay, there we go, that's better. So we got a problem with these. I don't know what's up with that. It should be constant. Um, oh, unless it's a random issue. That might be what it is. Anyhow, what I shall do is go back here, go to the transparency, put that back a little bit higher. Just make it solid. And you can look top down. We'll make these ones wood. This one will be metal. And we can see how that goes. So let's see this one. So that's going through like all of them. Let me get free cam. What does this one stop? Very slow speed. This one, couple in. Actually, probably prefer the randomness. And this one's just going straight through like nothing. Yeah, that makes a lot of sense. Yeah, that's pretty good. Yeah, let me put that into a Plinko. This one's a pen test. Let me shift them over there. Okay. That should be flipped around as well. That should also be over here. That one should be either of these. Let's see, that one, which will be the control board detail. No plan outfit. Let's go startup player. Let's chuck our walk speed to 100. I'm just gonna see if that overwrites. Like it doesn't. Alright, yeah, so that's pretty much the weapon system or the projectile system in at least. I'll have to get some weapons so we can test out the other stuff. This chunk load is a separate one. I'm just gonna see one of the other guys is trying to look at it, but let's just do that. Alright, let's go chunk loader. That's weapon system now. Oh, don't worry about that, that's because of the branches. So, this system's a chunk render system. So if we just load in, those still work, because that's nice. I need to open up this, I need to go here, just press OK. Let's play here. Leave my changes on. I just need to show somebody that. So this one should have the render system. So here I can walk in this area here, or this node. I guess I've got to fix that. So that's a node there. That one does that. That does that. Actually, that's weird. That should be. I guess multiple nodes for one thing isn't actually supported. Let me fix that. Upload a client. Okay. So for every active point, let's make a array for active instances here. Table.insert render instance. Is not using this instance unparented. What the hell? Stop branchy, Caesar. Won't you? I should fix that. So I can enter this area or this one. Shit, still isn't doing. Detail. Detail. Okay, if I remove that, is that gonna work like normal? No, VC. Yeah, that works like normal. That works, that works. So if I stand on this one, it's not working. If I stand on that one, it's working. Interesting. Let me see the table. Looking on the chocolate. Yeah, I just need to fix one issue. Which is, if you have 2 points using the same thing, one of them won't work. And then if you have a region with a node, it starts glitching out a little bit. Yeah, let me show you that actually. So if I do like region 2, that's going to be the control board detail. If I stand in there, it renders, but if I come over here in between them, you can see it's glitching. So I just need to fix that issue. That, however, should be working, but I don't know why it's not doing it. If I go in there, 1, 1, 1. Actor points. His visible parents. So that's within view of the character. And that's active. Oh, wait. I know what's up now. I need to do for every active point. For every active point, for render instance underscore yes. Oh, that's not very optimized. Oof. I'm gonna do that. I think. No. Visible, invisible, but it doesn't. Okay. No, yeah, that wouldn't work. That's not the solution. If it's within the point, set the parent. Unload points are not visible. If not table.find and not none. Boy. Actually, active instances, render instance. If table.find that, still active. In IPES point data blah. So what's triggering the detection or touch within regions? It's using quad tree system. If not, continue. Still active, add them. Okay, that might be better. For each point, if that is still active, that should be working. What? To set all of them to be visible, correct. So that shouldn't cause flashing, it's only this bottom bit that's causing flashing. Active instances. And let me do this. So if I say if not active table.find active instances, render, then add it. Same there. So now I'll print number of active instances. There's no active instances. If I run here, there should be one, which is the detail. I did something up here, didn't I? Render node part, replicant array, values. Render node part equals values, values equals that target parent. What if I put that out here? Well, I know it. I know when it's in and out. It's just harder for you guys. That's all. I'm just trying to see. Oh, node points, yeah. Because it's saying that it's in there, but it's not actually setting the visibility of it. So what I guess I could actually do is just I just did that. No, it would have to be out here. Active instances. Tail.insert active instances, render instance. So if not tail.find, add it in there. If not find it, add it in there. If local new active instances. May I just have it as one node per item? Yeah, because you can have a region. And then... No, I do need it like that though. What? What if I made it so each render node pointed to an instance which is hashed into a dictionary? So render node that goes instance to dictionary instance. So that's this here. And then I just have an array of instances and I just loop through that. What if I set attribute? No, but it's flashing because it's not keeping the order of checks. So if I have a table of all active ones, I remove it. Let me try it that way. Active instances is equal to that's wait, no, that wouldn't work with this layout either. I actually do want to change this now I think about it. It'll be render node, render region. That points to a dictionary of the instance. And I say dictionary instance active equals false if it's within one, active equals true. And then I can loop over through all of them. If it's not active, unparented. If it's active, parented. That seems like a better idea. Because then I don't need to do that there. I don't need to do that there. I don't need to do that there. Because all I do is just say point dot reference instance or dictionary, so dictionary square brackets, point dot underscore data dot reference instance dot active equals true, and I just do that for this entire loop here, for this entire loop here, and then just one copy of this goes down here. I like that idea. And I just have one loop that goes over this dictionary of all instances, check if it's active, set the parent depending on that. Yep, I'm doing that way. New chunk loader client.lua. So for this one, it's pretty much just copy and paste. Active points. So I'm gonna delete everything inside here for a moment. Wait, no. For point in character points. So this would be point dot underscore data dot reference instance cache dot active equals true. Same with there. I don't even need the new points array there, because what I'll do beforehand is say for reference instance data in pairs instance cache, so data.active equals false beforehand, and then here I say for data instance cache if data.active, so actually that would be reference instance dot parent equals data dot active and visible parent or render cache. Wow, that simplified it. That really simplified it. Holy. And that gets rid of that. That's the timing update. We do need that. Parent all active replicants to the world. The others to the render cache folder. Any character active. Should I do raycast checks as well? To do check if with an FOV. Check with an FOV if first person. No, that should be check if within FOV, otherwise do not set active. And then up here, what we have is, let me change this, get active quad tree points. Is that right? No, I want I do want a function named get active quadtree points. I need to comment that out, however. Let me disable this down here actually also. But focusing on this one, so what we have is in our setup. Let me just copy and paste this. That was a mistake, just delete that. So what we have is the also do that one. Let me move that actually down here. Okay, yep, so for each of those items, so for underscore render node, if there's an active cache array for that, so I do need that one. Local instance cache. So this would be a new empty table. So for each of the children, if it's not an object value and if it's not a props model, then child.value. So here, if not target instance, then continue. We'll warn that. I should probably explain what I'm doing. So we've got all these little render nodes here. Inside them, we've got these object models which point, or object values which point to a model somewhere in the workspace, or even replicated storage in some cases. And essentially, I want to have it so there's going to be two tables. One is going to be this node instance array, where this node part equals an array of instances that it takes care of, or like it renders and unrenders if it's within distance of this node. So this detail model in this control panel is controlled by this node, and this node. So 3 different nodes are using that one model. And the point is that if I'm within range of any one of these 3, that thing will be visible. If I'm not within range of any of these 3 things, then that will be invisible. So that's the whole goal there. So right now what I'm doing is saying, okay, check that object value's value. If there's something there, then I want to say the instance cache, which I'll do if instance cache target instance. We don't want to do anything, so if not instance cache target instance, we're going to create a new dictionary. We're going to have active equals false, and we'll have the parent value, which I think is visible parent. The visible parent equals a parent of the current model right now. So that detail model is inside the control board. So that active parent for the detail is the control board model. So now that we've got that stored in the dictionary, we can actually unparent this now and put it inside the render cache folder on startup. Okay. And then what we need to do next is say, okay, for my node, for every single one of these objects we've got, I want to add it into my array if it doesn't exist already. So here also, I'll say if not table.find the node to instance array, that's target instance. So in case there's duplicate object values, we can ignore it. I want to insert it into there. And then that's getting rid of that. And that's that essentially done. So here, I don't think I return anything. No, I don't. Alright. And then what I need to do in this active quad tree point data function, I need to loop through this node to instance array, which is the render node with the array of instances it needs to render. I'm not going to parent them in here. I need to check what type of node it is. So is it a single point or a region? So I'll get that, and also I'll get the position of the node. So that way I can either add a position or I can add a rectangle for that. And then I'll say, if there is no node type, so if the attribute's nil, it'll just be a render node, so a point. Otherwise, if the node type is a render node, which I should probably actually change to render point, then we're going to add a point into the quad tree. That's another system, you can search that up. Yeah. Yeah, exactly, yeah. Yeah, so I'll add a new point at that X and Z. Here, I probably want to minus half the node size. Size there. So that way it's the middle of the rectangle where the middle point is, not the top left. I'll add that into the point data and I'll return point data, which I'm already doing. And the replicants array here has a array of target instances. So that's like the detail model, these other models. So that doesn't actually contain the visible parent or active. That's in a different dictionary. This one's just an array of those instances. So that way I can change the active value when I want to. And apart from that, those two cache tables pretty much do everything. And I must say that's probably actually a lot better than before. So here the node to instance cache, that one we're going to keep, but the node points I'm going to clear. Oh wait, is there? So node instance cache, get active quad tree data. Yeah, so these two are permanent. This one is a temporary one, which will get cleared when this finishes. Yeah. Oh, check the camera's position, not a character-specific part. Oh, I do both camera and character. Yep, so disable that for each of the nodes. I'm gonna have to change this again for unscored, yeah, set all them to false. Reference instance dot parent equals star dot visible parent. Also I'm gonna toss away that. Node points equals nil, so that's that one up there. That tree's cleared, those points cleared. Instance cache is reset. And then here I set up. That one's there, so I'll set up node instance cache. Now that name actually matches. So now if I go in game Am I error? Nope, we're good. So if I go in this region, that's working there. If I go in this one, that's working. If I go on this one... Oh, no, it's not working. I'll see what this 123... Reference instances... Oh, yeah, I need 4 underscore reference instance in IPES. For each of them, that reference instance to active equals true. Same for this one here. Now it is render instances, not reference. So let me actually change that to reference instances. And this would actually be not replicant array, but instance array. Node to instance array. Render part to the array of them. Yep. Ah, that's what I just fixed raunchy. So if either the camera or either the character is nearby a node, it will set the node to active, and then it will render that. It's only if both of them are away from it now. It's like there. I'm in between these two, so this one's saying it's active, this one's saying it's active, that one's saying it's not active, but it's not doing anything. But because one of these two is saying I'm active, that's active. So this region saying I'm active, these two are saying nothing. This one's saying, and this one's saying I'm active. These two are saying I'm active. This one apparently doesn't work. I need to fix that. I believe that might be because of the tag view as well. That is why. There we go. Render node instances. That was missing. Is that in there now, permanently? Yup. I group that. Change group. Client rendered. There we go. That's why I rescripted it, or that piece of it, so that way it's better. Oh, found release some new UGC. Let's have a look what he put. We've got... Oh wait, hold on, let me get that avatar on. Let's see what we got. What it wetsuit? Oh, there we go. Oh, that one's okay. I don't know what I use that one for. This one's pretty cool. So I might get that one. Not that one. This one. He got tagged. Okay, yeah, but there we go. So now, I think it was just because of that, but... Eden Pro, okay, Eden Pro, that sounds familiar. But the render system's fixed, I'm gonna push that, because that's actually important. I can also get rid of the old one now, so get rid of this one. Put that one in. And it should be one, yep. So that's a major correction. Character auto loads should be false. Yep. Okay. Major correction. Instances. Oh. Render instances. No longer flash when within distance of 2 nodes that share a model. A render model. Optimized. That's a lot better. A blank suit, yeah. I was gonna say, like, goddamn hell. Okay, next one. I want to see in here. Does folders have a pivot? No, it does not. Okay. So here I want to say if reference instance is a what has attributes? Roblox not attributes, pivot. It's a pivot PV instance? PV instance? Position velocity. Yeah, PV instance. Okay. So if it is a PV instance, then else. So here I want to actually do I need to actually go back up here now. I want to say if it is a PV instance, else pivot to yeah, so there'll be a difference now. So if it's a PV instance, we're going to try and move it away a really far distance. If it's not a PV instance, we'll just unparent it and parent it. So here we'll do dot PV origin get pivot, and then we'll pivot to local super far cframe value cframe.new 9099 9099 9099, and I just want to see performance difference between the two. So if it's a PV instance, we want to not parent it, but reference instance pivot to the origin or the supervised keyframe. Okay, there we go. Now we've got different types of things happening. And here, actually, I'm going to do local cache data. Let me do that. There we go. So if I get close, it's there. If I get far... Okay. I need to test this in a really big map or something. If I just duplicate this over and over. No, I have to wait till... No, but I want to drop memory too so mobile can play. So I don't want to do this quite yet. Without testing it. I'm gonna have to wait until we implement it into the map. Let me add a to-do here. Test, and if it's worth to use pivot to pivot to hide the instances. Why not simply set the transparency? That is a horrible idea. For example, every one of these is a part. Oh god, and that's also a fucking thing. I forgot about that. So you can already imagine how many parts that is. Yeah, I'll tell you how many parts. Game.selection, get one, get descendants. Number of them. Ah, that's 5,760. Yeah. And that's just for that. That's not including all the other stuff in the game. This is the bullet penetration cutoff. Okay. I'm gonna move that into... Oh shit, where did I put it? There it is. What's this one? Momentum. Oh, yeah. Roblox, active project, Snoot. Leave that there. Okay. Oh, yeah, let me also point that one out. Pivot to... what do I even call this? This is the pivot to set parent. Pivot to implementation. Read description. Let petition Roblox to add an instance.geometry visible property. Well, that would be for base parts, mesh parts, and unions, not models anyways. So it's kind of... When I say did add it to models, or maybe not folders, but definitely models. Memory usage. Is fast. Saves time, adding it back to the render engine. Cons. Higher memory usage. Mobile/console. Test on large map. Alright, there we go. Is it actually, let me see. Does it show up here? Yeah, it does. That's great. Like folder render descendants. Yeah, I guess that's true. How would that be implemented though? Because if you turn it off, does that mean you're going through each instance under the folder and disabling render geometry? Or in the graphics engine, do you have to keep a like cache of which triangles belong to which mesh, and you have to check if that mesh is visible or not, or the geometry option or render descendants option is enabled or not, and then only if it is enabled then render them? Because if you did it that way, you'd have like 2 or 3 extra, or not even that, like 5 extra things to do per triangle. And if you didn't do it that way and you said, okay, just remove it from the render engine, it's pretty much the same as setting the C-frame super far away or unparenting it from workspace. Actually, no, it would be the equivalent of unparenting it, even if it's still under workspace. Because you're removing it from the render engine. Yeah, no, but Roblox adds all the triangles on the render engine. Actually, no, how would they... when it's unparented, how would they keep it? Oh, maybe it might work, I don't know. You can make a dev form post about it. Make a dev form post. Yeah, that's done now. Okay, gun framework's working on. Going good. Radio system, that's frequency thing. I could do some of that. No, I can't because I need UI. Need the radio UI. Gun guns to test the gun framework. Gun launch portion of map. Launch. Yeah. We do some UI. Holy fuck. How long have we been streaming? 5 hours, 41 minutes. Yeah. I'll do more of the main menu. I need to do some of that. Where is the main menu? There it is. Alright, I'm gonna have a quick break again. I'm probably gonna get some food. Hell, I need to fill up my water, take this to the sink, go for a piss again. And then I'll be back and we'll do some main menu.
get me, but you stayed by my side when I said, don't try to make yourself remember, darling, don't look for me, I'm just a story you've been told, so let's pretend a little longer, and when we're gone, everything goes. You and me, hanging from the willow tree, quietly drifting in the open breeze. Suddenly, the wind blows you away from me. Now I see we were never meant to be. If only we could travel back in time. Whoa, right where we belong. Maybe we'll never need a reason why. Whoa, dancing till the dawn. If only we could travel back in time. Whoa, right where we belong. Maybe we'll never need a reason why. Whoa, dancing till the dawn. Born from the same branch and leaves, wild and free, living here in harmony. Don't you see? This is where you want to be. But when you leave, the world is never what it seems. If only we could travel back in time. Whoa, right where we belong. Maybe we'll never need a reason why. Whoa, dancing till the dawn. If only we could travel back in time. Whoa, right where we belong. Maybe we'll never need a reason why. Whoa, dancing till the dawn.
What is reality? I want to know what you're feeling. Are we sure about this? This is the time. This is the place. This is the song. More. Welcome to level 1.
Nice. What are we doing? Main menu. Let's check. Yeah. Oh my god, I lost it. There we go. What am I gonna do first? Okay, let's have a look at the menu first and see what there is. Oh god, you're gonna hear me eat now. I need that one to the bottom of it. No, that's gonna be hard for me. Oh dude, this song's a banger. Okay, 0.65, 0.5. And then I can move all them down. Customize, I'm not going to worry about at the moment. This menu's kind of fucked. I can do that. I can do that. Okay. I want to do credits, shop. Maybe options. And infos, whatever. Okay. That goes to 2, that goes 0.65. 0. that one's the menu frame, so I want my home frame. I'm gonna move it down slightly. That one's gonna go down slightly, and that can go right there. Okay, that's constrained, so I don't actually need to worry about that. If I try that... I'm just trying to organize the frames a little bit, make them scale properly and stuff. That's better. I'll pick scaling for that one, that one. Now. Home. I need that in there. And that's corrected. Options frame, refresh frame. Okay. I kind of like it like that. Don't know. It's fine, it's fine. Home frame done, shop frame, let's fix that one. Boy, that looks miserable.
Don't give in to the sad machine, to the TV screen.
Okay. That's better.
When it's hard to find, when it's cold outside, I'm alright out here in a lost land. Heartbeat like
We should have an aspect ratio, not aspect, template button, template from rect, template square. Hero grid layout to a list layout. Horizontal. Is there no... Or is it a page layout? Table layout. Sure, this one. What the fuck? Sure, it was a page layout. Was it not? Yeah, Fat Rat, yeah. It's just the Ultra Gaming track, where the fuck that is. Oh my god, this fucking song. A canvas group. Oh wait, I know what I can do. I can have a frame, one with squares, one with rectangles. I have grid layouts inside of them. I have a list layout for this one. This one's a vertical. This is 1, 0, 0, I guess. No, I should have grid layout there. 1, 0, 0. And what, these are scroll layouts? No. Yes, those are scroll layouts. No, they're not, because I want... Why make it size Y? Oh, 0.2. Oblivion. That's pretty dang nice. And if I delete a bunch... Hey, there we go. And then I have a label. This is, dev product header. White text. 0.0. I'll force it to the left side. What's this one? Gotham. Game pass. Header. Game passes. So it'd be dev product header, layout 1, the squares, layout 2, game pass header 3, rectangles 4. Which is correct. And then padding, let's just add 0.1. Goddamn. Okay, so we've got obviously currency in our game, so that would be what these ones are for. Game Pass wise, I'm actually not completely sure. I think it's gonna maybe not be as much as you may think. Maybe like 1.5 times experience multiplier or something like that. But a lot of our benefits that you can get are in-game leveling, or through in-game leveling. So let's say you're a class D. If you do a couple of tests, you rank up to a different rank of class D, then you get special benefits for that. And one of the special benefits could be like 20% stamina regen increase, or 20% stamina regen speed increase, and then like 5% running speed increase, stuff like that. Yeah. One should actually be center. Look around. Can we get... Oh my god, still. No, you're not getting my balls.
We're always tipping on our toes without an antidote. You got me high on feelings. You're always rushing through my veins. Yeah, from my head down to my core. We're coming off the ground. We're never coming down.
Oh, I can't even increase it. Wait, I can't increase it? Huh. Oh wait, no, I know why. I want to, I'm gonna do that. I'm gonna do that. This one can scale up. Should probably scale up top left one. Can we see your mom? Oh my god. Science team. Science team. How does that go again? I forgot. Please give me no Nathaniels. Or Nethers? Oh, I have the answer. Yeah, so shop is done, homes done, customize not worrying about, credits, I can fix this one easily. Okay. Credits, shop. Let's do the credits first. Main menu. So, credits frame. So under our credits here, actually I mean credits config. So local credit config mod module, replicated modules, data.credits config. I'll move that to the top in a moment. We want to get the frame for the credits as well. So that is indeed under main frames, menu frames, credits.list. So under our credit config, we've got for user ID credit info in as credit module dot yeah, for that credit config. Local clone template equals UI template credit frame clone template dot name equals user ID. Do I have a? I don't. Okay. Maybe I should facility. Maybe I should add a priority. Let me do priority. Anium 1. I'll go 2. Connor G. Under 3rd. Surface engine not there. Deported not there. I can add people later. I'm gonna get rid of people that win. Not there. PG's there. Watcher. Zeox. Not there. Chaos. Oh, shit, I was in the wrong channel, that's one. Let me go back. Let me check again. I'm gonna get rid of that. PG's here. Watch director. Sloth Zeox. GKO sounds familiar. Is this something? GKO's nope. That's 2020. Jesus. Energy is here, syntax. This is the Grim Reaper. That's 2020. Hysteria. Question of ethics. Thirsty. Oh, deleted user. Okay. Snoop. Building deer. That sounds familiar. Oh, 2020. BMA. One kill. PMA. Is he in the Discord still? Oh, he's still in the Discord. Let's go. Anarchy. PG's alt. And me. Snoop 1, 3. Well, that'd be 4, 3. So priority 1, 2, 2. Oh 05, 2, 2. Three, 4. Yeah, I'll add people data. To add people. Shoot the way. Santa. Or I should just copy the name. What's your name again? Cyprine, that's right. Cyprine. Let's use Cyprine. Deported Imperial. Who else? I don't know about you. BMA is a Penny. 2, 4. Sorry. Top. Okay. Now that's done. Clone.layout order equals credit info dot priority or 99. Local user thumbnail equals. I go to that one. That's base thumbnail URL. Base user thumbnail URL. Actually, it's layers get user thumbnail sync user ID 150 headshot thumbnail type dot headshot enum dot thumbnail size dot size 150 by 150. Icon the image is that. Put that in a new thread. Just wait for it. Clone template dot username dot text equals players get user. Get name from user ID is sync user ID. Leave that in there as well. Description dot text equals credit info dot description. Clone template dot job equals credit info dot job. And done. Then clone template dot parent equals that. And then I need to do widget made give template clone along with that. I need that one in here as well. Clone template. If I put this back now into there. Job is no value of frame. Job.text. If I go under credits, everybody should be there. Okay, frame's got scaling issue. I got an idea. Okay, let me play it. Copy that one. Paste it in here. And voila, I now have all the different frames. That's fine, that's fine. That's fine. Don't need to worry about the home tab. That's completely fine. Don't worry about customize. Has shop. Shop's fine. Credits is an issue. Okay. Now this is a scrolling frame. There's no automatic size there. There's automatic size there. Now why is that so huge? Why is that so huge? What the fuck? I do 0.5. Oh, that's better. Look at that. Right, so that's the credits list. I'll copy that list frame. List, paste. Okay, menu gone. What's this one up there? Nice credits, nice. Maybe I'll add a padding to it. And there is a padding. That's actually username. No, that's on the hard left. That's hard right. Me, all of these just need a... Yeah, they all need it. Okay. Template credits frame. Description. Boom boom. That's better. Now in the shop frame, I do actually need to fix that. Can I add a padding? Yeah. That's better. Let's do that for the padding. UI padding, scroll under shop. Okay. Do we even have game passes on the main page? Let's have a look, shall we? Snoop. We are going to this one. Dev products. Okay, there's none. No game passes, okay. I'll have to do it the nice way. Load all game pass frames, etc. Which I need the marketplace service for. Set type dot place. Oh wait. I want to see what information I can get from that. Print game dot marketplace service. Dot place dot experience. Let me see how it's done again. Roblox, get dev products and game passes. Let me go to inventory. Process receipts. No. Not what I'm looking for. Roblox marketplace service. Get dev products. Oh. Get developer products. See. Okay. And how about getting game passes? Let me rent game.http service. Require no get a sync.
Do you wanna meet all my monsters? Think you're tough, I know they'll drive you bonkers. Meet 'em once and they'll forever haunt ya. There's no heroes or
String.format, blah. I think this is gonna get blocked by the Roblox API, I think. Place ID. Ah, unfortunate.
I've tried and tried a million times. Cross my heart and hope to die. Welcome to my dark side. Take a step into the heaven. Look around the scene, even the half of it. I'm walking the line between panic and losing my mind, embracing the madness. My devils, they whisper in my ear, deafening me with all my fears. I'm living in a nightmare. Parts of me I cannot hide. I've tried and tried a million times. Cross my heart and hope to die. Welcome to my dark side. Cross my heart and hope to die. Welcome to my dark side.
Okay. I'll have to do the game passes menu. It's annoying. Credits config, that's fine. Let's do premium config. We've got products, we've got game passes. Let's add them in there. For underscore the product ID and IPs. Game pass and IPs. The player game pass ID was purchased. It was purchased, then frame equals main menu, main frame, menu frames, shop, container. Container.scroll.rectangles. Find first child, the game pass ID. Nice. If frame, then frame dot icon dot image color 3 equals color 3 dot new 111. Goddamn. Template shot correct. Template shot where? Okay, let's get a premium config, let's move that, and let's move that up here. So the credits frame here, let's also copy that to here. Local shop container frame is the container frame there. Dot scroll, dot rectangles, find that. Local template frame equals template shop. Was that square? That one's rectangle, so RECT. The name of this one is the dev product ID. Local product info, marketplace service, get product info, dev product ID, enum dot product, no asset type dot dev product. Or not. Oh, info type dot product. If not, and you can see all return. For this one, I do want to actually do that. Dot squares. I want dev product info. Is there a template information? Oh, here we go. I want the icon image asset ID, which will be going into the RBX asset ID // There will be the description text, no, description dot label dot text equals target info dot description. We've got the title. Info dot name. Description. Price in Robux. I'll make sure that's larger than 0. iPairs, that would be the premium. Product IDs. Look at all of them. Also, we want to give it the template frame, the button, the activated, connect function, marketplace server prompt, product purchase, local player, their product ID. Got that there. Shop rectangle. Shop rect. So Game Pass ID, Game Pass ID, Game Pass ID. So that is actually purchase, Game Pass purchase. And that is into the rectangles. Now the frames are not different, right? The same thing? Yep, same thing. Okay. Sweet, that's all of them. Okay. That premium one is going to the top. Premium config. Hey, I'm just gonna test the game. So credits done, shop's about to be done. We'll just make sure that's working. We don't need that one either. Under shop, there's no buttons because there's no game passes. To-do label there. Yes, I need to do this frame here next. No, that should. Let's look at it. Menu frames, home, one frames, play, team info. Is that scrolling enabled Y? Automatic Y. Why is there a gap there? Is that the padding? not. Why? It's being weird. Oh, I guess it's just slightly. I don't want to, makes sense. I'm gonna fix it, okay. Play frame. Home button frames, play frame. Home button frames, play frame. I'm gonna make sure I download a copy of this too. Don't forget that. Roblox actors, no rework.
So switchy.
What is this? Shop and credits. Shop implemented or store. Store dev products and game passes. Oh, I don't have the server side for that. Oh snap. I need to actually do that. Premium service. Never mind, it's already there. Store and credits page. Store implemented. When adding IDs, make sure to do server side handlers as well. Credits page can be configured via module script. And we want to also note that did some UI corrections, still some tiny issues. See, that. Okay, main menu. Oh, if local player is equal to player and was purchased. Event correction. Okay. So, chunk loader is implemented. I can merge that with the main branch. So I need to Unneeded print. I'm gonna push that. And then I'm going to go to the main branch. I'm going to choose a branch to merge. And I'm gonna merge that one. Now is that correct? Yes, yes, yes. Push. So chunk loader. Oh wait, no, I don't want to do it that way. I want to revert changes. I want to go to the chunk loader here. I want to create a pull request. I'm ignoring my own fucking system. Okay. So that one's create a pull request. That'll be main. Chunk loader goes into main. Chunk loader. If I switch to main, it does not have the chunk loader. If I go back to the chunk loader. Okay. So create pull request. Pull requests. No, not main menu. Chunk loader. What is going on? Why? Main is at what state? Okay. I've got to do this properly. Chunk loader. Okay, so I'm gonna grab squash and merge. Push origin. No. Why is that thing a bitch? Chunk loader client. Is that the one I want? Okay, that's the one I want. I'm sure. Okay. Main. So now if I tried to that again. So what does main have? Main doesn't have a great pull across. Okay, there we go. Quad tree render system. Um, oh wait. Scripter. So guys, I'm just doing some of this other stuff. Essentials. Hey, Stampy. Butchery's open, okay. Chunk render. And these aren't ready yet. Okay, so chunk render is going. Let's go back to the main menu. What was it? Settings. Oh boy, settings. That's going to be fun. Okay. Let me just close a bunch of this crap that I don't need right now. Okay. So when you do settings, settings is in here. So I have, is it global? No, it's client settings. So these are the settings you can toggle. Of course, we'll have more later on. Gameplay, bullet trails, bullet holes, bullets, flash. Um, Guns, bullet trails, bullet holes, flash, weapon sounds, camera type, oh, camera, camera system equals type equals select, options equals over the shoulder, third person, first person. Get default config value. Let's do config.
like a battlefield. Chilling in a coliseum, I'm getting ready. I'm Maximus the gladiator, in the middle of 10 alligators, entertaining. Living in a simulation, you don't need to
Parent
understand it.
equals
Go along,
parent
have fun with it. I
plus
slide to your
1.
room and see you standing there naked. Come on, let me play with it.
Not back to parent, then false. Return if type of active parent is equal to table. Let's return active parents. So if number of active parent is equal to 4, then return active parent 4 default value. Also, if number of active parent is equal to 3, then return active parent 1. Actually, no, that would be fine.
On my way to find a way to plant a seed, to cultivate a pollination with you when I come and take you, get you, break you, come inside you, fornicating on this rhythm in the kitchen. We create new kind of power with a serum. In the mirror, I see some kind of monster with some kind of a mind, trying a little bit of candle burning, turns to Raja King, Shaka from Zulu.
There we go. To say like get default config sounds dot notifications. Config path. Could not find setting. Active value. If active value is a table, if one is number. Okay. So we got that done there. So that's like our get default config. We can validate in config option that the player is trying to change. And then inside the player's data, there will be a gameplay settings override, which is like the path and then the setting we chose. Also, I need to go into here. I'm going to actually put that there. Now, in my simulator projects, let me open that up. I need the data replicate. That is very important. So let me move that over here. Let's add a new core data replicate. Wait, yeah, data replicate service.lua. I'm gonna get the essentials, so we need base framework. And then it's just a bunch of utilities and functions. It goes inside the starts. Change that, change that. We change that, we change that. That one. Change that one, change that one. Change that one. HTTP service, HTTP service. Now this is under core, so we can get the require replicated modules, and we want the remote service. And under the remote service, we want a data replicate event. Thank you. Thank you very much, Copilot, for figuring that out. So under here, we're going to fire a specific client. It'll be that player. We're just pretty much telling them to update the data. This one is going to be fire all. Yeah, is that a different one to this one? No, it's not. Yeah, they're all the same. Fire all clients. Fire all clients. Fire clients. Client. Fire client. Fire client. Fire all clients. This one is fire client. That is fire client. So this one we're telling them to update. We're telling them to update. This one's on server event. Remote. Oh, what did it call it? Oh my god. Event. Data replicate events. That's half right. Firewall clients, fire client, firewall clients. On server event, fire client, fire clients. That should be the server side of that done. And then under the core for the client, let's get the data controller. So that is data replicate controller. New module, this is data replicate client.lua. Okay. So a lot of it is similar to this, so I'm just going to do that. So we have active data cache, table, bit data, blah blah blah. Nothing too crazy. So then this will be module. Event, the on client event. So I'll do these ones real quick. So controller is just module. This one's data file server. Okay, event class module. Open modules. Classes. Events. Here I'm going to just do new. And change it to update events. Now we've got data replication. So this now can be sent to the client. So if we go into the player data under our on player added, we can set data, their data replicate service. So that would be actually systems container dot data replicate service. Set that for that specific player, and then we can also remove it from there as well. And make sure we've got our stuff there. Yep. Now that should replicate to the client. So actually if I go here and I say what is this? Game passes, load all game pass. So this is load all dev product. Load all the game passes. Update game pass icon when purchased game pass. Then we need to do settings. So we're halfway through that. I don't know if I have a settings one set up yet. Wish I did. Client widgets. Yeah, I don't really have a settings yet. Let me quickly check if I have any other projects. What would it be under? Might be under that one. That's where it's originally from. Have I done anything related to it? Client config, sweet. Client config service. Client config service, lower. Module init, function, module start. Edit config, config path, string. And then what we can say is function module get client config value. Actually, I'll put that under. No, I'll put that there actually. System container data service. You want to get the player's data. No active player data, active data. I should name it player data. So under player data, we should have a table, gameplay settings override. So here, when we say get client config value, what we'll do is, no, I'm gonna do that in here. Get client config value, the client settings, cache, return. Oh, let me do config path string. If client settings cache config path string, then return that. Return get default value for that. Okay, and then when I want to get a config, get player config value, local player config path string, I'll just do return get config option, config path and the cache. There we go. Let client config function module clear client config option local player config path string. Get their player data config path string equals nil. I'll just do that. We can get their config, we can clear their config, we can edit their config, and then I just need the remote event to do that. Which under the main menu, which we would do. Now, before I move ahead, do I want to... I'm thinking of splitting this into sub-widgets. I might leave that as a to-do. Split into sub-widget modules. Let's find this simple. Yeah, I think that would be better. Whoa. All right. Where is it? Let me get... Let me get none for lower chat. I totally forgot about that. What is it? Oh, verified email. That's right. That's what you need. I'll leave that on. Okay. Yeah. I think that's good for now. I'll probably split these into sub-widgets. Yeah, I'm gonna just split them in sub-widgets. Let me get rid of that. Site where we are. Okay, so this is data replication. sudo menu. Split menu, main menu into sub widget modules. Edit. Data replicate. Data replicate client. Alright, let's push that. Alright, thanks everyone for watching this stream. I'm gonna end it here. It's been a nice 7 hours and 40 minutes. Pretty valid. Long duration. Haven't done a stream like that in ages. But yeah. I'll see you next stream, or I don't know when that will be. I might do one tomorrow if I feel like it. Maybe not 7 hours and 40 minutes, but something like that. Yeah. Hope you learned something for those that have been around for a bit. Especially with the weapon framework. Yeah. See you around.